morning, my friends. I clean my room. You're a good man, Charlie Brown. You know, we hate AMD, we hate AMD, we hate AMD. All my homies hate AMD. Let's not hate AMD, let's pity AMD. That's what we do on this stream. We pity AMD. You know, you just like, no, did they open up they're not gonna open up their firmware. They're not gonna open up, oh yeah, you think they're gonna meet that Monday deadline? You think there's any way in hell they're gonna do that? No, I mean, look, Lisa Sue responds to my emails. We had a nice exchange back and forth. She's very polite, but she doesn't say anything. It's emails that again are just like, they don't say. It's a style of communication that you see a lot in business where people just literally don't say anything. Like, why don't you just? I'd much rather you say like "fuck off" than like write me 3 paragraphs that use the words like partnerships and strategic, right? Like, why don't you just talk like a person? So again, very nice, which makes it hard to be like angry about. But, you know, you got to be a little bit smarter than that, right? Like, you got to look past. I engaged with AMD over 100 emails, multiple Microsoft Teams calls, and they gave me nothing. Right? They gave me absolutely zero thing of any sort of substance. So, you know, I don't know if there's like a word for this behavior. Again, if you're not exposed to really how, like, it seems like, I don't think business used to be like this, right? I don't think like Walt Disney or Henry Ford acted like this. I don't think they would, like, you know, I think Walt Disney and Henry Ford would be like, you're an idiot. Delegate, no, I'm not delegating to someone that's not triggered by business and knows how to navigate. No. You see, when you give up on your ideals, you lose everything. I love that line. LA told me you'd be a pop star. All you have to change is everything you are. It is the managerial class. You know, again, look, Qualcomm's CEO doesn't even reply to me. Jensen went for a ride in the NVIDIA in the Comic Car once. You know, which is interesting. Thinking back on that, it's obvious why you're going to be successful. I don't think that. Bill Hewlett gave Steve the spare parts to build his frequency counter. Yeah, like, I mean, it's not going to change. I guess you get these sort of people who end up running these companies who, like, it's very much like a don't rock the boat sort of strategy. How hard really is it to make your own chip? It's not. We're gonna make our own chips. Look, we're also still likely going to get AMD on MLPerf, and we're here working with. Okay, so the mistake that I made, so that nobody repeats this mistake, do not work with the company. Work with the product. Okay, don't waste a minute thinking about the company. I don't know why I didn't realize this with AMD. I did realize this with the car companies. I realized that there's no way we're ever going to talk to Toyota and ask them, Please, sirs, can I have the steering API for your LCAS module? Uh, I just knew that was impossible. I don't know. And maybe when I started comma, it was the same crap, right? Actually, when I started comma, I took meetings. The amount of clowns that came to my office, like total and complete clowns. The Rolls Royce guy would drive us around in a Rolls Royce and take us out to dinner, right? And then you realize why he has this job. I did realize this with TensTorrent. What do you mean, realize what with TensTorrent? No, look, I think that TensTorrent is an underdog, and they're not really like, they don't feel like they have a lot to lose, right? In reality, again, like TensTorrent looks leaps and bounds better than Grok, for example. I'm the Toyota CEO, and here's your API. Remember also that I think that these people are so encumbered by like lawyers and license agreements and stuff. Again, I wish there was just more. I guess I don't like the style of communication. I wish there was more just honesty. Like, George, we can't open source the GC. The GC is, we have 3 agreements with these 3 shit companies, and they have these terms, and we just can't open source it. Why don't you just say that? You know, just be honest instead of this. Again, it's very nice, but it says nothing. Right? It tries to communicate a feeling instead of like a thing. My experience with Qualcomm made me think AMD responding to me was legit. Yeah, I think that's part of it. You know, we're just trying to navigate. We're just trying to change the world here. We're just trying to. I'm kidding about the like, you know, look, the by Monday thing is not a. You reply to that tweet and say, look, it's going to take 6 weeks for legal to get things together. Here's 2 docs that we know we can release, right? Like, look, I understand it's a process, but I didn't get anything like that, so. I never worked with Parma Lucky, but I met him a bunch. He's cool. So I mean, yeah, like what do we do? So I think I know what we're gonna do on today's stream. On yesterday's stream, we wrote a. Oh yes, I've met Jim on multiple. I've hung out with Jim on multiple occasions. These guys are Jim Keller, Palmer Luckey. They're even Elon Musk. They're very much what they seem to be. I think that you'll understand who they are by watching any of their content. I guess what's so weird is, like, you know, just you can watch some Lisa Sue content and you understand exactly what you're gonna get, right? You watch some Jensen content, you understand exactly what you're gonna get. I guess you watch some me content, you understand exactly what you're gonna get. It's not politics. It's just like. What it is that they don't want to be great. They don't desire greatness. Well, no, I didn't. There's no need to ask Apple or Nvidia. Have you ever seen Apple or Nvidia? Have you ever seen their driver crash? No. I don't think I've ever seen Apple's driver crash. We have a bug now with the Metal Graph API, but I'm sure it's because we're not using it right. I've never seen like Apple's driver behave in a way that looks like there's race conditions in it. I've never seen Nvidia's driver behave that way either. Right? This is just yeah. How is Intel so far? The guy in Discord saying that they had an 8-guy meeting with a VP. Like what, I'm picturing a gangbang, man. Like that's all I can picture, you know. Do I think a new architecture can help AMD, or is their firmware going to suck forever? No, they have to desire greatness, and that's you can lead a horse. You know, they just. Oh, you're running it on Power 8. Well, I don't know how to help you, man. Get an AMD EPYC system, run the NVIDIA driver. You'll never crash the NVIDIA driver. So Lisa Su has to go? No, I don't know about that. I just think it's a real mismatch of, you know, Tinygrad desires greatness. And AMD doesn't. AMD desires to be second tier NVIDIA for slightly less money. And I don't think... Well, Tinygrad desires to be the best machine learning framework. We live in a lot of things today like that are winner take all. Like, I do think it's going to be pretty winner take all. I know greatness requires time. I'm not saying it doesn't require time. Tinygrad is not going to be great tomorrow. It's not going to be great in months. It's probably not going to be great next year. I'm thinking about 5 or 10 years. I think there are some engineers at AMD who feel like I do, but honestly, I think less and less. My guess is what happens in cultures like that is, like, no one who desires greatness will tolerate it. I'm saying that my interactions with AMD showed me that what they desire to be is always second place. Is always media. Well, you know, the firmware was, you know, it's not great, but like, so why would anyone buy this? Do I think the Radeon division needs a new CEO? I don't really know. Like, it's hard to judge somebody without understanding their goals. And not everyone's goals are greatness. Not everyone's goals are, you know, truth and beauty. Does Tinygrad aim to be high performance across hardware partners? Well, providers. Oh, good. Yeah, we do. Generic solutions don't fall short. Just think about the bitter lesson. Is it easy to switch to another graphics card? Yeah, we already switched to video. We are on our first try. We trained a ResNet on 6 4090s. Yeah, I can show you the ML perf log. I just like if we had run that and the NVIDIA driver somehow crashed, I would have been shocked beyond belief. Like, I would have taken 10 to 1 odds against that happening. And of course, on the first try, the NVIDIA run succeeded. It's just as fast as the AMD, and it will be faster. Like all the optimization and work we put into AMD, just NVIDIA just beats it right away. What do you think about Grok? Why did anyone fall for Grok's stupid demo? Some guy in here yesterday was like, I get 400 tokens per second on 2 A100s, and I believe him. It's a meme. It's... No, and actually, AMD's in real trouble because what's going to happen... No, Grok... I can't believe people fell for Grok. No, Zluta's not going to help. No amount of... Like, the only thing you can do in user space is mitigate. The problem with AMD GPUs goes down to... It's not in the driver, it's in the firmware. And there's a chance it's not even in the firmware, it's in the hardware. The GPUs may very well be broken at some deep hardware level. Are they really that bad? Yes. don't buy whatever your budget is, buy a less powerful NVIDIA GPU at that budget, and you will be so happy you did. I mean, if you're a masochist and you enjoy pain and suffering, purchase an AMD GPU. And like their process is not going to. Oh, did I figure out what architectures used for the firmware? We could do that on the stream if you want. I'm sure we can figure it out today if we spend all day on it. But I think we're gonna do something else. But you're just gaming. So what's gonna happen in gaming? If AMD loses too much market share in gaming, the game manufacturers are gonna start saying this just isn't worth it. If it takes any more effort to support, it's a negative feedback loop. So as gaming becomes worse, less game manufacturers, and as AMD gets a smaller market share, less gaming manufacturers want to put any effort into supporting AMD, right? If I'm testing my game, but only 2% of people have an AMD GPU, why am I gonna spend resources here? Yeah, I mean AMD's in PS5 and Xbox because do you want to try to work with NVIDIA? Do you want to? We tried to buy chips from NVIDIA. I'm sure the big companies have the same problem. NVIDIA wants way too much money. This is look at the Tesla NVIDIA thing. My understanding of that is that NVIDIA wanted a large amount of money from Tesla for compiler support, and Tesla was just like, we're making our own chip. So that's why consoles are AMD. As a render programmer in AAA, we always have to cover special edge cases for AMD drivers that crash. Exactly. And this is exactly what I said in my email to Lisa. I'm like, what you are doing is you're not root causing issues. You're writing mitigations, and you're writing mitigations at every layer of the stack. If you don't root cause an issue here, you write mitigations here. And now if you have mitigations here and root problems here, you write mitigations here. And you write mitigations here, you write mitigations all the way to the application code. Do Intel GPUs suffer from the negative feedback loop? Well, Intel GPUs don't have any market share to begin with, so no games work on them. How did their software get so bad? It was always bad, and they have no real desire to change it and make it better. With the AMD chips desoldered themselves? You know why Apple doesn't have any NVIDIA discrete GPUs? Is that up to AMD to fix their shit? I mean, the problems lie in okay, so they talk about a scheduler in their firmware, and they talk about how the scheduler deadlocks occasionally when they're using an in-order queue. So they switch to an out-of-order queue. You can't switch a deadlock by changing an in-order queue to an out-of-order queue. That makes no sense. Right? All you'll do there is you'll make the mitigate. You'll just make it harder to trigger. Right? You'll just mask the problem. I knew a software engineer that worked for Radeon, and he switched to working for NVIDIA. This stuff might be why. Yeah. Again, they're not going to take me up on my offer. It's not going to get better. Something may trickle out that's open source from firmware, but they don't understand what would radically be required to compete with NVIDIA. You know what I'll say about Snapdragon? Rock solid GPU driver. We run the, oh God, I even think about it. Imagine we were running the OpenPilot model on an AMD GPU. I have never seen the Snapdragon GPU do anything bad. We run that OpenPilot model 100% reliably, pretty much. No, I don't think AMD's engineers have bad intentions either. I don't think Lisa Su has bad intentions. I don't think anyone there has bad intentions. Again, like I said, I can fix Qualcomm with power overnight. I can't fix AMD. This is a much harder problem to fix. And I may very well again, I don't know. Lisa Su's more successful than I am, so I don't know. Who am I to question this, right? Maybe there's some strategy I don't really understand, or some goals I don't really understand. Whenever someone's acting in a way that doesn't make sense to you, they just might have different goals than you. what would be required to fix this? Deeply, no, I'm not even gonna call this the managerial class actually. Let's see if this is so I had a dinner with a bunch of people in Taiwan, and there's a bunch of OpenPilot people. OpenPilot's pretty popular in Taiwan, and just, you have a couple of beers, you start talking about culture. I think that it's more of a like cultural, don't sort of like rock the boat. Whereas like contrast that to, if you read Elon's biography about what life's like in South Africa, right? going to some like what is it called, like Welt school or something, No, it's not a shame culture. It's kind of like it's a more cooperative. It's a more cooperative culture, a less individualistic kind of, Veld school. That's it. A risk-averse culture. And one guy had a couple beers and he was going off. He was really like, the Americans fucked us, man. It's like we do all the hard work here to make these chips, and then Nvidia goes and sells them at a 90% markup. Jensen seems pretty individualistic. Yeah. Look, it's not everybody. I'm just like saying that if we're trying to like understand this from a lens that makes sense, right? It's like not a like bold moves aren't going to happen. AMD can't afford to make moves. Why not? I don't know. I shouldn't say that stuff. Like I'm not trying to like say like, oh, that's the culture and all people from that culture are like that. I'm just like that's a lens with which I can interpret the behavior that makes more sense. Yeah, they have the consoles, the CPUs sell. They get something going, they keep it that way. And yeah, it won't get better. The AMD firmware is not going to get better. The AMD driver is not going to get better. Yeah. What is this? Wait, a bit more expensive? I'm cheaper than that. I'm 10K cheaper than that. What are you talking about? Yeah, it's similar to this. I have a better processor than that. I have a better SSD than that. I have half the RAM, but you don't need RAM. You think you need RAM, you don't. I also, is this have the full? But yeah, no, I mean, what? I'm 10K cheaper than that. Oh, you mean their product? Yeah. Well, it's good to know that that's like a price. How do you mitigate the lack of P2P? Well, we're going to get there. So we have, our AMD stuff has 12 gigabytes per second of all reduce. Our NVIDIA stuff has, not our NVIDIA stuff yet, but we can get 5 gigabytes per second on the computer because it has to go through host memory. So the all reduce is less on the green Tinybox and the red Tinybox. But I have a theory that once we get to just the I/O control layer, we don't even have to go to the driver. We're going to be able to mitigate this. The AMD's enterprise stuff has the same bad firmware. The enterprise stuff, you may hit the bugs less because their strategy doesn't seem to be like when you. I reported to them multiple bugs, and the bugs were fixed, but they were not fixed in the right way. Like you don't. When someone shows you a bug, you don't figure out how to tweak things to make the bug stop happening. I mean, you can do this, but you do this, you're always destined to have bad software. When someone gives you a bug, you have to root cause it. You want to really understand what caused the bug and then fix the underlying issue, not paper over some stuff until no one sees the bug anymore. And I mean, that's their strategy in video games. It seems to be actually the way that a lot of these video game things work. They don't root cause the issue. They just say, okay, Witcher's using this shader. If Witcher, do this. They have great hardware people. Yeah, the hardware seems great. I don't affect the stock market. I do think the only effect I ever had on the stock market was the time Mobileye tanked 7% after Tesla released the statement. No, I don't even think that AMD stock is necessarily going to go. The only thing that I can say 100% definitively about AMD is that they are not going to leapfrog NVIDIA in machine learning. That's the only thing I can say. Oh, it'd be nice if they were explicit about hacks like that. It's kind of like, and maybe that's why they don't open source the firmware. It's embarrassing that they probably have a hack in there that references Grand Theft Auto 4. Like, Grand Theft Auto, I was running Vice City on a PS2, What is the problem with AMD? The engineers or the executives? The problem with AMD is that they do not desire greatness. They do not desire greatness, and they will not get greatness. AMD hasn't leapfrogged NVIDIA in about 13 years, and if everything continues like it is, they won't leapfrog NVIDIA for another 13 years. Isn't it generally okay to work around bugs in the games? It might be. It might be. So if you're targeting games or you're targeting fixed function ML inference, this strategy might work. But if you're targeting ML research with flexible frameworks, this strategy will never work. Well, I'm not going to build a GPU. I'm going to build an accelerator. Is it common to use the same firmware? I mean, what do you mean by the same firmware, right? It's kind of like the same way the same Linux kernel runs on all. The processors are great. The EPYC processors are great. They don't have firmware issues. I don't have my EPYC processor locking up. We're going to build a DSP, yeah. AMD settles at number 2, is the simplest way to put it. Maybe they should make a separate firmware and driver just for ML. And maybe I was offering to do this for them for free. Right? That's literally what this is literally what I wanted to do. We're going to use NVIDIA now rather than AMD. Yes, we are. Okay. Here before sub mode. That's the perfect time for sub mode. So, how do we want to start? KFD Ioctl. Do we have this somewhere? User include Linux KFD Ioctl. So let's start by building. We'll call it KFD. Tinygrad has these things called autogen here. we'll create one called KFD using that. And we're going to need the KDEF fun. Any of those Clang args. It's not called co-manager, it's called KFD, base KFD, fix up KFD, KFD. Don't need that. Yeah. I do like how simple this API is. This API is like so much simpler and cleaner than so let's see if we can switch over. Is it the same as this? Or is there more to that one? It looks pretty much the same. Okay, that's cool. So let's see if we can switch here. From importing this, we can say from Tinygrad runtime autogen KFD import as KFD Ioctl. So let's see, Ioctl equals 1, HSA equals 1, Python test ops, test tiny add. Is it tiny add or add tiny add? I never remember. Okay. We're missing this. Are we even using that crew one? Is it the same CRIU, like the checkpoint and restore in user space? Okay, where's this comprehension here? It's here. Oh. Well, I'm doing something else here. Instead of doing that, let's just take this path. No. Okay, cool. So AMD's, we looked at the NVIDIA one yesterday. It looks a lot more complex than AMD's, so that's kind of why we're starting here. Oh, let's also, I think it's HSA KMT debug equals 7. Maybe it's not that. HSA KMT debug level. Okay, that's there. Oh, I guess we can't use more either. Wow, that's a lot of events. I can just use less of those. Let me just go to HSA and use less of those. Not that HSA. There's so much HSA. HSA has kind of gotten out of hand with how much code it takes up in Tinygrad. So we're gonna try to cut back on that and go right to the lowest layer. $496. That's so many out. 356. Sorry, the text is even small for me, but we need small text in order to see. So we're going right down to this low layer here. Nimble then Jen just said we have to do the memory stuff, so let's hope that's true. I don't know what those IO controls are. All right, let's start with a get version. Could we not use the RockM userland stuff? We're not actually going to rip out HSA. We're going to support this. We're probably going to still end up getting AMD on MLPerf. It's upsetting. I don't know, the lack of a desire for greatness just upsets me in people. Like, I would so much rather somebody say that, like, we desire greatness, we just don't think you're great, than, well, actually, we want to be middle of the road, you know, it bothers me. No, we didn't do anything on this. This is my hobby. This is a real waste of time. Like, I should not be spending time on this. But it's Saturday, and this is what I want to do, so, you know. Everyone has hobbies, man. Wait, where's get version? How does that... Oh, what? Oh, that's annoying. Why is that not a... Okay, we need that code then. Yeah, we need ioctls from header. No, we really need... Oh, that's so annoying. All right, well, we'll deal with this later. No, it's not. Some people just want to be happy and you don't need greatness in life. Yeah, it's fine if you're an individual. I just don't really want to associate with you. Like, if you're a company, like, what are you doing? All right, so what are these numbers? No, okay, we're gonna wanna write some code to be able to send these IO controls, which is less easy than with the NVIDIA ones, it turns out. So when we get this working, you'll just be able to install Tinygrad on a new version of Ubuntu, and you won't have to install any of AMD's userspace. So let's what I want is like KFD dot AMD KFD Ioctl get version. Should we just start writing a parser? Structs are all there. It's like just this one that doesn't. Why are these commented out? Oh, maybe because I don't, maybe I can just fix this by including whatever that is. Yeah, like this almost works. Let's see if I can just fix it by including that. That'd be sick. Where is that defined? Linux IO control. User Linux IO control. Oh, actually, we want to put it first if it matters. Does that fix this by chance? No, same shit. Do we need to define here or something? Oh, well, okay, that's just nothing. It's not actually following includes. Oh, there's a flag to follow includes. Let's try that one. Well, we might not need anything if we just include that flag. No, just more broken. And I mean, it's cool that it expands the macro like that. We did something, but it's still, what is all this crap? No, I don't like this. All right, should we write a proper generation thing for this? Structs are all fine. It's really just this one thing that's wrong. Let's read the source document. I don't want to parse that like that. It should just be a Python. You have to know the size of the struct. What are these calls? We haven't even gotten to these calls yet. a 0 and a 69 targeting dry render. What are those things targeting? Wow, this is harder than I thought. What are those things targeting? Why don't I print the name of that there? Let's go here. Dev KFD. Great, I printed it right. Let's just check to make sure it's right. Okay, dev KFD. So we're gonna have to open dev KFD. What mode do we open it with? So we need an FD, so we probably just want to use os.open. An strace, so let's take a look. That. Is it open 64 or something? To redirect that. Direct open. Open add. Yeah, okay. What's clo exec? What does this do? Oh, it's about the. Well, that's cool. Oh. There's a really cool issue in Python. The multiprocessing is broken because it uses fork instead of spawn. And all the FDs stay open because it's clo exec. Oh, it's wild. Okay. They're opening it with ORWR, so let's just do that. Let's change this up a little. Let's do, I want to create an object. How do I create an object that's not a dictionary? I'm going to use eval. It's like set adder or something. Oh, here we go. All right, so we want a dictionary with name and then a tuple of an int adder. KIO. So now hopefully I can do some something like KIO dot AMD KFD, I don't think it's a version. Who thinks that works? It works, but it's annoying. I just don't like that it's. We want to like call it with that struct. We want to create a function. You almost want to like generate Python. That's probably the way to do this, right? Like don't do this dynamically, just like write out Python code. I don't even know if those are inputs or outputs. All right, let's just do one by hand, and then we'll do it faster. Okay. So we have the number. We need like the reverse of that macro. Yeah, this. Put it in reverse. Either size, itype, nr. Okay, so Python OS, how do I do an IO control? I have to import IO control. I don't do this here, don't I? Oh, I actually do it as a syscall. Yeah, that's fine. It's an F control, it's a mutate flag. Mutate flag is created. The buffer is passed. The buffer's new contents about the action. Okay, buffer seems true usually. Whatever. F control. .io control fd. Our request is an IO control number. Okay. So KFD version, oh, it's like, look at the different Q types. Q types, Q, Q, Q. Q, Q, Q. Should we listen to some royalty-free chiptune? Royalty, no. Creative Commons chiptune. long playlist. Free music archive. Just love YouTube. Who thought this was a democracy? Did I balance it well? Yeah, I think so. Don't overflow it. that to capture. Who understands why I'm writing this? Pay attention. You want to learn to predict what's going on. KFD version. Let's actually put the struct first. One of these. Open the GPU. extensions, bro, they're never gonna make you good. Okay, we have to figure out what the 69 is. What do we think that is? This is like knitting the GPU. I'm sure this is where GPU ID comes from, so we have to understand how to parse these. It's the API. DRM info. Oh, we have to get DRM. Oh shit, I saw this. It's actually included. Go to this. Yeah, drm.h. Where's drm.h? Number 69. 69 in hex. 45. No, 45. Is that already in hex actually? Oh, it's in Radeon DRM. No 45s. Not good. Not good. So what IO control is that? 0. Is that a real one? Version. I'm sure this is where GPU ID is coming from, right? Here, acquiring VM for BF for E4 using 7. So this 69 is probably... I did that right? Yeah, hex 45. And is it an IOWR or an IO? It's an IOR. Actually, wait, no, that's not an IOR, that's an IOW. Not any of those. What's I type? Do I do that? Oh, I type there 100. So what's 100 in sure? Lowercase d. Is that DRM? Has to be. it definitely has the DRM IO control base. But the number is 69. I'm pretty sure, okay, GPU ID is not returned. Yeah, we're acquiring VM for, I don't know, you know what? We can read the runtime. Let's just read the runtime. Runtime. So not VS code. So I'm pretty sure that's where that print statement comes from here. Acquiring VM for? No, it doesn't. So it's not in here. Oh, it's in rock teeth thunk interface. Fine. Okay. Acquire VM takes in. Acquire the VM from the DRM renderer. Crap, man. No, I know it is D, but where's 45 is my question. Okay. So, yeah, they can call acquire VM. That's great. But where does... No, not DRM render FD. I'm not even worried about that. Debugging, no. Close DRM render IDs. What is this? FMA allocate device. Map to CPU, blah, 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 blah. Allocate device, maybe? Okay, memory object. Alright, so here's where we open the device. Maybe it's in this initialize thing. Where is that function? Where's the function? What is that linking to? Oh, here we go. Could that be in here? Ah, libdrm AMDGPU. Here we go. It's probably here. Sorry about hitting the table. I know it's loud for you. Wow, we got a lot of viewers again this morning. People are into this stuff. That's cool. Or you're into the AMD rants. Or you're into GPUs. What are you guys into? turn off subscriber only for a minute. Why we got so many viewers this morning? You're into GPUs? GPUs are hot? So where is 45? We're not trying anything. We're just... Guys, it's over. The Tinybox isn't shipping with AMD. AMD offered to buy all our GPUs off of us. Maybe we'll take them up on it. I'm not shipping this shit to people. I have standards. So what is that thing? What is that? What is that function that's being called? Okay, we have to acquire the VM. Is the next thing we have to do. Why are you guys constantly worried about, like, are you joking about being sued, or do you actually go through life worried about being sued? Like, take it from someone who's been sued several times. It's fine. We're suing someone now. We're suing this woman hit her car and didn't have car insurance and didn't want to pay. She had some car insurance, but it wasn't enough to cover the damage. So I'm suing her. I'm suing her. This lawsuit's been pending 18 months now. Nothing's happened. You like AMD and hope they'll fix it. They won't fix it unless they change their culture. Like, their culture is the tolerance of mediocrity. And, yeah. Again, if you're looking for a mediocre GPU that kind of works, buy an AMD. You know, the other thing that you don't understand about suing someone is, so what you do if you're on defense is you just delay, and you end up costing the plaintiff absurd amounts of money, like more than they're ever going to recover from you. That's kind of the strategy. All right, never mind. Now we remember why that we go to subscriber only. Yeah. I take pride in what we ship. I don't want to ship shit to people. You know? Oh, what's the poll? You don't know why you're here. Great. You go through life. What do you go through life? What else don't you know? Okay. Whatever. Let's go to rock teeth thunk interface. We're gonna have to figure out where this thing comes from. GPU ID. Where do we set GPU ID? Where does a GPU ID come from? Oh. Interesting. So it may not come from what I thought at all. Retrieve the GPU ID. It looks like it comes from sysfs. Is there actually something in there that talks about the GPU ID? No. Validate node ID, GPU ID. Oh, here. Get DRM render ID. How do I get GPU ID? Oh, these are interesting. Lib HSA KMT. So I can get this from sysfs. Here we go. Device virtual. Why do I have two of them? GPU ID. 0. Don't use that one. What about that one? Oh, that looks better. Okay, well that's where that GPU ID comes from. So that's nothing we have to dynamically allocate, so we can just go back here and we'll just manually put it in. Sys devices, virtual, blah, blah, blah. Now we'll call this DRMFD. Okay. Now let's create a struct called acquire VM. ST. Acquire VM. ST dot. Oh, I wish these could autocomplete, but they can't. DRMFD equals DRMFD. Let's throw an underscore there to match. Love when things match. Check GPU ID. Alright. Works. Cool. Did we just acquire a VM? Wow. What am I going to do with this VM I just acquired? Hello, we're streaming. Good morning. We're streaming. We just acquired a VM. Virtual memory, I believe. All right. You're bullish on Intel? I'm not bullish on Intel. I had 8 guys had a meeting with a VP to figure out how to solve my problem. What the hell is my problem? Microsoft would have acquired the VM. Okay. All right, good. We're acquiring a VM. Let's set memory policy. Wow. Can we allocate memory of GPU? What do you mean of GPU? Let's just see if this works. Where's the header? Okay. We pass in the VA address, we pass in the size. Where do I get a VA address? Can I just make it up? I can't just make it up, can I? Where did that come from? Mmap offset is input or output? For CPU mapping, for user pointers, this is overloaded. From KFD, mmap offset. Oh, that's reasonable, I guess. Virtual address of the memory to be allocated. All later mappings on the GPU will use this address. Where does that address come from, though? By the way, remember that most hacking is very boring and looks like this. So if we want to look for exploits, this is how we do it. Newbie programmer showed up and said, "Hi, what are you doing? You don't know why you're here. Great. Well, I'm glad you're here to watch me. We love having you here, but only some of you. Okay. We're getting -1. Let's see if we can figure out why we're getting -1. No feedback. Just error. Only error. Oh, we have to give it a GPU ID, of course. Tell it what GPU we're allocating the memory on. No better. Nothing. Okay. Where is that VA address coming from? Let's strace mmap. Create events. Okay, here's where the VA address comes from. Wait, no. It's almost that. Almost comes from mmap. Wait, it comes from that mmap? How does it mmap it after? Oh, what? That's weird. Map anonymous, map private, map no reserve. It's not even mapping that on an FD. Do I just like get an address like that? I don't know, wanna try it? Let's look up Python's mmap. File knows -1. Length is this. Flags. Private. Man, Lil Wayne. Who misses Lil Wayne? Oh, I don't think that's actually going to give me an address. Closed false, access equals access read. How do I get prot none? We have prot none? Prot read, prot write. No, we don't have prot none. That's not supported. Okay, we need to get the address of that mapping. Accessing shit is possible with shit. Okay. C-type, C-int from buffer. Does that work? 32 from buffer. This fails if I map shared. What? Supports the writable buffer interface. Get address of read only. Okay. Oh, that looks terrible. FFI from buffer. That looks terrible. There's no way that works. Oh, there's like a... I've done this before, and there's like a nicer way to do it. So hard. What is that? What type is that? Yo, we can't listen to copyrighted music. Hey, can we get Wheezy? Can we listen to your music? That'd be sick, man. I bet he'd be fine with it. If Lil Wayne's fine with it, are we good? Are we good to listen to copyrighted music? I love listening to copyrighted music. Can I increase the bit rate? No, you get less bits. Bits are expensive, man. We can't do it if it's read only. I don't know. What if we just do mmap.part right? Now it's not read only anymore. Error. I want to just get that value. I feel like I've done this before. Maybe even in Tinygrad somewhere. No. No luck. Underlying buffer address is not writable. So this is just crazy. So I first mmap anonymous memory, and then I map it in. Are there docs on this shit? Not that. I didn't even get that. KMT IO control. Okay, FMA allocate memory object. Void pointer memory. Args VA address. Where does this memory come from? Aperture allocate area? What is this, portal? Allocate area aligned? Man, like you get to the bottom of this and it's like one simple little crap, but like you gotta find it. Right here. It just calls allocate area aligned. Oh my god. No, he sold. No, Wheezy, why you sell out, man? Universal, man, they're evil. Memory mapping of files in the mmap. Yeah, but can it get me an address? I'll get the address. I don't know. What, you know what I have here? You can just read the driver. Let's read the driver. See what the driver says. Here we go. All right. Here's the driver. Host bar. Oh, wow. Oh, we can allocate doorbells. We can allocate all sorts of things. What are we allocating here? This isn't like, you think that like we're not even close, but we're actually, this gets a lot easier as we, like allocating memory is half of the battle. Once we can allocate memory, okay. Allocate memory of GPU, then we map memory to GPU. Then we map it read-write with this offset. Oh, I see. You see what we're doing here? Wow, that's a crazy use of mmap, right? Like that, I would think that would be like mprotect. Like look at this crazy use of mmap. I didn't even know you could use mmap like that. Map no reserve. It's also not a flag. We have to find map no reserve somewhere. What does this do? Do not reserve swap space for this mapping. All right. That doesn't seem useful, actually. Yeah, we don't do that. All right, so how do we get the address? Let's just solve this problem. Underlying buffer is not writable. It still has an address. I can see an strace. We have this buffer, it's just not writable. It's also not readable, so that sucks. Mmap, closed, access read, pause, offset. Why does what return null sometime? Get the address. I feel like maybe I've done this in C types before. There's some like, it's not returning null. Maybe I've done this before. I'm gonna have some like helpers for this. I have like these like from MV and shit. Here, C types address of, but that's not gonna work if I can't. I think this doesn't work. I think it's not a C types object, and it's going to give me like crap. Yeah, invalid type. We can try. We can't make it from a buffer because C types doesn't support read-only buffers. I've dealt with this crap before. Cast it. Is there an os.mmap? We might be able to use like a deeper. I mean, if we have to, we can import mmap from libc. That will definitely work. But I'd rather not. These are the small downsides to using Python. want to just do this? This will definitely work. All right, what are the args to mmap and libc? Address 0. I think it's 0. It's 0. Yeah, null. That's the size. Prot 0. Flags. Private anonymous. FD is -1 and offset is 0. Right, let's see. I think it was a good address. The Fed's been spying on all of our shit. You're allocating memory of GPU? No, we're still getting an error. Okay, that didn't fix it. Walking around with their chest out like Janet Jackson and shit. Alright, can we get more information on this error? Oh, it's probably because we didn't, of course, we're going to have to set the memory policy. Oh God, you know, if I wanted to set policy. All right. What kind of policy do we want? Trying to itch your eyes? Don't scratch them. 3 eggs. Okay. Alternative aperture base, alternative aperture size. GPU ID is of course the I love using APIs like this because it feels like I'm actually like talking to something and not thousands of lines of crappy C written in a crappy way, like to ensure employment. How many lines of code exist in the world just so people can have jobs? Default policy 1. Alternate policy 0. Okay, well, setting the memory policy works, but we still can't allocate memory of GPU. Maybe we need no reserve. Do we need no reserve? I don't think we do. Oh, also, wait, it didn't actually, I added 1,000 here. I think it matters, but no. Okay. Why is map no reserve different? Oh, we have to check the architecture. That's probably right. 4,000, you'd say? All right, we still can't allocate memory of the GPU. This does not work. Oh, we might have to get some apertures. Do we get any apertures? We did not get apertures. Do we get apertures before or after we acquire the VM? Okay, we get them before we acquire the VM. Where does this memhandle aperture start come from? What are these things? Do I need them? Two apertures overlap. Knit memhandle apertures. Memory of GPU. Let me stick the nmap offset into there. But what else is happening here? All right, you want to do a better? You want to do a bigger S trace? I'm trying to figure out what's going on. AMD is not going to give a shit, okay? I'm just making that clear to everybody. It's not going to get better. If you're buying an AMD card and thinking, oh, this is going to get better, like, I'm sorry, but you're deluded. Like I was deluded. We all were deluded. We believed it might get better, but it won't. Oh, what is this M-bind? I don't even know what that is. M-bind? Have you ever heard of that? Enables the AGP aperture. Interesting. I don't, Alex, you know how I feel about questions like that. Just however you think they're good. I'm not a very picky person. Except I demand greatness from my GPUs. What is M-bind? What does this do?
Oh, fuck.
What happened?
I was like really trying to develop some of my chef skills.
And the eggs are on the floor. Yeah, I know. I've tried chefing before. It always ends badly. Chefing? No. What's MPOL default? What is M-bind? What is M-bind? Oh, Numa! I don't care about this. I don't think this matters. Wait, then we M-unmap it? Before we do this?
I'm sorry, the third egg's on the floor.
Oh, thank you.
Let me know if you want more.
Oh, the third egg's on the floor. Oh, we saved two of them. That's pretty good, man. That's like Titanic numbers.
I'm gonna close your door because I want to wash the dishes.
Okay. Your wife sympathizes with Alex. Let's get some unmap. Do we have to unmap the address? What just happened? I am a Mormon, and a Mormon just believes. You cannot just believe part way. You have to believe in it all. All right. How do we... Oh, I know what we can do to debug. Let's check out our driver shit. have some high quality debugging shit. Let's go. All right, look at this progress. We're at 22. All right. What's 22 again? Why didn't you guys answer my question? You're talking about eggs. What's 22? Invalid argument? Okay, hang on. We might have glossed over some stuff. Okay. mmap offset. 2 KFD from user. What user pointer? What's a user pointer? Do we need flags? Oh, maybe we need VRAM. That seems reasonable. Are they passing in flags? Oh, look at all them flags. Flags. What if do we just need some flags? Let's figure out what these, wow, look at all these flags, man. All right, that's some flags. Let's try some flags. Let's see what we got. Oh, it worked. Great, we got a handle. Oh, did we even have to set the memory policy? Or was that just a scam? I don't like setting policy. We didn't even have to do that. Do we even have to acquire a VM? Ooh, how nice would it be if we didn't have to acquire a VM? Is that a requirement? You have to acquire a VM. That's very reasonable. We're happy to acquire a VM. All right. alloc memory of GPU. It's pretty cool, right? Okay. We have a handle and an mmap offset. And now we can use Python's mmap. I don't even know about this. Did we need to munmap it? We didn't. That was fine. Yes? Wait, you came for the plate? The plate's not done. Why do you want the plate? The wire, right? You got to push it out.
It has nothing to do with the wire. It's stuck up here.
Well, there was an earthquake and now our apartment sucks. You want the plate? Well, that's aggressive.
Well, I'm wanting to wash it.
This is like when they come at the restaurant and they take your plate. Go, oh, are you done with that? You don't know. I was fucking eating.
That's exactly what it is.
That's right. Okay, so we've alloced the memory of the GPU. That's pretty cool. It's so weird that I give it a VA address though. Like I don't like that's a weird API, but whatever. I don't care. Okay, now we can mmap. On the FD, length is st.size. Flags are what flags? We love flags. Don't mess the flags up. Last time we messed the flags up, I get like a sense of deja vu. Like I did this once before and I messed the flags up last time. Map memory to GPU. But didn't I already allocate it? I don't know. Map shared, map fixed. Those are normal flags. Wait, what? Make sure we got the right arch and shit. VKI, it's probably this. No, can't do fixed there. How are these args different on different platforms? Okay, map fixed is 10. Map fixed. We passed in the FD. Now we also need to pass in the offset. Oh, access. Access is easy. mmap.read, mmap.write. I mean, I'd love to exec, but you know, can't ask for too much here. I wish it could autocomplete on the ST, but it can't. And map offset. So we're going to say buff equals that. Let's see what we got here. Signed integer is greater than maximum. Wait, oh no. Is it the offset? Operation not permitted. I think it's the offset. Oh, that sucks. libc.mmap. Alright, so what are the arguments? Address. Oh. Wait, oh, I can't even give it an address in Python. Oh, this doesn't work. Okay, yeah, we have to... VA address. It should be a lot easier, I think, to get from a pointer. VA address, size, what's next? Prot. Flags. FD. And offset. Okay, cool. Actually? Huh. Whatever. Okay. We allocate the memory of GPU. We can see what's happening. Let's go. Actually, let's add a time sleep here. Mapping MMIO page. Target user address, physical address, VM flag, size. I wish I could just see into the GPU. Like, what's that doing on the GPU? Domain CPU. Create BOVA. What's a BOVA? Why do I have to map the memory to the GPU? I alloced it on the GPU. I don't understand. Also, I'm kind of curious what flags we're passing. That's a later thing. Okay. Passing a handle, a device arrays, gotta make a pointer. Device IDs, array of GPU, and then the number of map memory to one or more GPUs. Okay, I guess that's reasonable. Whatever. We have to take the handle from here. We end devices. Assert stm.endSuccess equals 1. There were all sorts of bugs in this crap too, in the user space. I forget how I got around them. Map memory to GPU. No, but like I allocated it on the GPU. I don't really understand why I need to device IDs array pointer. I need to create maybe just do something like C types GPU ID and then get the address for that. Did not work. Device ID array empty. Okay, well. Oh, because it's passing in. That's very strange. How do I allocate an array in C types? Recommended ways to create an array are dumb. Pointer instances are created. Oh, do I want a pointer? Incompatible types. LPC it. I have to cast it. Wrong type. Where's my Python struct for this? It's in here. device ID's array pointer is a uint64, but that's gonna bitch me out because it's like, well, you can't cast a pointer and not a pointer. Object doesn't support item assignment. Oh, well. Okay, now we just need to cast that correctly. Even though it doesn't want to cast it. Oh, I might just be able to do address of. No, again, we're getting this crap. Why is n devices that and n success that? Okay, that doesn't seem right at all. Oh, passing in the wrong thing there. Oh. Okay, oh, I forgot I added a time sleep. Okay. Great. So here we map the VA to the VM. One BO size. One BO address before DMA mapping, one BO address after DMA mapping. Great. So I think that's allocating 4 kilobytes on the GPU. I like how fast that is. We're only 5 milliseconds in. Okay. Here's something I don't really understand. How did I just mmap GPU memory? Does that just go over the PCIe bus? Let's create, how do I do C types from like a raw pointer? Memory view object from address C types. These things are like so annoying. Because I can't use Python's mmap here because I can't pass in a VA. Bye-bye. pointer C types pointer val. No, you can't just do that. We can try it, but I don't think it works. Pretty sure that don't work. Type must have storage info, yeah. We'll probably get this working. Oh. Actually, it should be a void pointer, right? Problem is it's a void pointer. So we should be able to cast it. C types pointer, C types, say like human date or something. No, I did that backwards, but I think this works. Then, if I want to make a memory view out of it, maybe memory view dot con. Oh, I see. I should maybe just 2MV will work. Size is 10,000. Alright, cool. I think that works. I don't know why the memory's there, but so I don't know. Let's we're writing AA to the GPU. No, it's always 255. Why is it always 255? So I think we can also allocate memory on the CPU and make that memory accessible to the GPU. Or can we map any memory? No, we need a handle. Oh, wait, no, that buff's correct. Passing the VA address, map, prod, whatever. Why is that just... Okay, and success is working. So we definitely map the memory to GPU. No, this is right, I'm pretty sure. I don't think it's wrong. How do I use 2MV in the rest of Tinygrad? CT from MV. Yeah, that's probably right. I'm probably just doing something else wrong. I don't know, maybe just the memory policy? That stuff's all super annoying. So I don't know why I'm over allocating there. I might not need to do that. Do we need to unmap it? It's crazy that that works, by the way. So this is basically only being used to get an address that I can pass into this. Maybe the wrong address somehow. I'm not actually totally sure about that. Okay, so what type is this? It's a LPC char object. How do I get the actual cast to avoid pointer? Wrong type. Okay. All 255s. Good math there. The memory buffer doesn't extend there. It doesn't make sense. Whatever this is definitely not normal memory. But I can write to it without a seg fault. Okay, you want to see the seg fault? We can try this. Yeah, there you got seg faults, right? Still don't know if this memory is supposed to work. Okay, did we hit the target user space address? Yeah, that's right. Let's check what these flags are. Maybe the flags matter. Our problem before was flags. Our problem again may be flags. Not hit by Ioctl. It's not the one I want. Where's the one I want? KFD Ioctl. Where are the flags? The flag's not here. No, this is tragic. Where are my flags? They're definitely in this file. NVIDIA CEO says you're going to be replaced. I can't believe that shit. Of course he's going to say that. Imagine you're replaced with a... I'm not even engaging with that. Never mind. I take it back. I regret engaging. It's too stupid to engage with. He's trolling you. And you're falling for it. Oh, okay, good. It's in here. Wait, those flags don't even... That's not GPU memory. Oh, we're getting rugged, boys. We're allocating MAO remap? Oh, we getting so scammed. Oh, we're getting so scammed. We're getting scammed like... Alright, well, those aren't the flags we want. Let's find some better flags. I knew it was flags. So when we allocate normal GPU memory, like here, what flags do we use? These flags. Oh, different flags. Let's see what other flags we have. Ooh, those are flags too. Look at those flags. We're going to have to do all this again for NVIDIA, too. Ooh, F001. Those look like good flags. What do you think of those flags? Some of these have to be real flags. What happens if we allocate like that? Segmentation fault. Interesting. Don't try to read and write to those flags. Okay. Actually, does that just work totally differently? No, I'm still doing this VA address garbage. NFT memory? Who's got NFT memory? look, they're allocating, you know what this is? That's a guard page. They're putting a guard page on each side. You guys know about guard pages? Sometimes you gotta guard things with guard page, like castles. GTT, what's GT? Why do I feel such deja vu doing this? Like I've done exactly this before. Did I do this on another stream and I'm just like forgetting it? Okay, VRAM, memory type. Well, it seems like if we allocate VRAM, it's segfaults. Let's try to read the VRAM before we try to write the VRAM. Oh, well we got, okay, never mind. As soon as we got that there, we should assert buff not equal to that. Wait, what? What's even giving me that? Where's that print? That? Okay, the remap is failing. Oh, I see. I probably can't mmap that. Like, even though it has a VA address, I probably can't mmap it. Can't mmap that. That has a completely different issue. This is the only one I can mmap, which is MMIO remap. But for some reason, it's full of 255s. Which I guess I don't totally understand. What is an MMIO remap? Oh, so writable is the first number there. So this has writable, this has writable, this has writable, this has writable. D is also includes executable. What? These are also executable? Okay, whatever. You do you, man. Did I count that right? Yeah, let's count it right. All right. Public. Oh, this one's public. These two are not public. And there's just no substitute here. So definitely no substitute. No substitute for any of these. MMIO remap. Let's see what we can learn about this. Let's go into the driver and let's learn things. Here's the driver. Are there like docs on this? No docs. MMIO is mapped through KFD device. Wait, MMIO? You guys know what MMIO is, right? Memory mapped IO. I mean, it's kind of crazy. Oh, this is interesting. Look at the FD there. I might just be using the wrong FD. It's not the GPU RAM is on the DRM device. Which I guess kind of makes sense, right? So let's do GPU RAM. I don't even know about the MMIO. Alright, so this buff asserts. Okay, it buff asserts, but I have an idea. If we change this to DRMFD, it won't buff assert anymore. Ooh! Look at them 190s. I don't know what a 190 is, but let's see if we can write an AA there. AA is a little aggressive. Let's write 101, named after my favorite California highway. Oh, it works. Great. All right, I think that memory might actually be on the GPU. Let's take a look. Can't tell. All right, I kind of feel like I want to shower. So that's going to be break time. But that's pretty good. I think we got some GPU memory allocated. So I think our goal for this stream is going to be to execute a kernel and have that kernel modify the GPU memory. Just take the GPU out and see if it works. Yeah, I don't think that's how it works. How can we check if that memory is actually on the GPU or not? It should be. Domain VRAM, that's pretty cool. Wow. So who thinks we can map the secret GPU memory that contains the firmware? What did they call it? Oh, it had some stupid name. Who thinks we can map the, what was it? What was the stupid acronym for it? Let's look at my notes here. See, this is what I mean. You gotta keep it all straight in your head. The TMR, Trusted Memory Region. If we could map the TMR, oh, is writing speed the same? It's gonna be hard to measure. Yeah, we're not really gonna be able to measure that, right? Like, 'cause how would you do it? I could like memcopy is slower than the PCIe bus. How do we see if transactions, is there a way to like debug the PCIe bus? What do you mean cat from dev 0? Linux sniff PCIe bus transactions. I don't believe so. We have to buy some expensive ass shit. Wait, this is actually pretty cool. I kind of want one. Like, that'd be sick. Let's look at the TLPs and shit. Does the memory start zeroed out? No, it doesn't. It starts with 190s in there. What's a 190? BE. I don't really know what that means. What flags are we doing, by the way? VRAM, writable, executable, public, no substitute. Actually, I'm not even sure I need to do this. Do I need to map the memory to the GPU? Not sure I do. I mean, I might need to later, but for now, yeah, I don't have to. Okay, cool. So we're just allocating some memory on the GPU, and then we're mapping it using the DRMFD, which it makes sense that it's the DRMFD because the DRMFD varies per GPU. There's only one KFD for the whole computer. Yet these, you want to go into a tinybox? Which one are they playing with? 13? If we go into tiny 13 here, yeah, look, you can see, because there's 6 GPUs, it has 6 DRIs. Pretty cool, right? Good thing I'm a member of the render group and can access it. How many viewers are going to stick around if I go take a shower? I woke up, I went right to this stream. We acquire GPU memory. Let's do a little bit more than we usually do on streams, and let's make a plan. Okay. Step 1. Allocate GPU memory. Step 2. Execute GPU kernel to fill GPU memory. Step 3. Read GPU memory. The beauty of this, we're not going to have to install a single piece of AMD crap in userspace. This is all just the kernel driver. Their kernel interface is a lot cleaner than AMD than NVIDIA's. The fact that it's like in one file like this, they have normal. NVIDIA, you're like allocating all these things, which is, I think part of the reason is, you know who we have to thank for why this doesn't suck? Linus Torvalds. I bet their API was like awful, and then Linus was like, no, you want to get merged into the kernel? I want you to be a reasonable adult and not do this. So yeah, I think that's why this API is nice. Versus NVIDIA, who's not in a Linux kernel, and they write an API that, oh, well, just allocate a device and a sub-device, and no. It has nothing to do with, in general, complex things work less well. NVIDIA's firmware works because, again, I'm a talented, promising young graduate. Do I want to work at NVIDIA, who wants to be the very best, or do I want to work at AMD, who makes Rickle? Like, it won't get better. And let's see if we can find the part about, yeah. By the way, like, BoJack Horseman's like my favorite show of all time.
Died and all I got was this free churro. You know the shittiest thing about all of this? Is when that stranger behind the counter gave me that free churro, that small act of kindness showed more compassion than my mother gave me her entire goddamn life. Like, how hard is it to do something nice for a person? This woman at the Jack in the Box didn't even know me. I'm your son. All I had was you. I have this friend, and right around when I first met her, her dad died. And I actually went with her to the funeral. And months later, she told me that she didn't understand why she was still upset, because she never even liked her father. It made sense to me, because I went through the same thing when my dad died, and I'm going through the same thing now. You know what it's like? It's like that show Becker, you know, with Ted Danson. I watched the entire run of that show, hoping that it would get better, and it never did. It had all the right pieces, but it couldn't put them together. And when it got canceled, I was really bummed out. Not because I liked the show, but because I knew it could be so much better, and now it never would be. And that's what losing a parent is like. It's like Becker. Suddenly you realize you'll never have the good relationship you wanted. And as long as they were alive, even though you'd never admit it, part of you, the stupidest goddamn part of you, was still holding
I love Lost as well.
chance. And you didn't even realize it until that chance went away. My mother is dead, and everything is worse now.
Yeah, it's like Becker. It had all the right pieces, but it just couldn't put them together. And when the show ended, you were sad because, you know, it could have been better, but now you know it never would be. All right, we'll let you chat amongst yourself. Give me 10 minutes. I'm gonna take a shower, and then we're gonna do the plan. Read GPU memory and confirm kernel filled GPU memory. We can actually start to do a lot of cool low-level stuff here. Amaranth style shower stream. Y'all don't want to see that. Okay. What time is it? Back at 10:35. Put in Tinygrad. Do fun tests. Put in Tinygrad. Okay, so I had a very productive shower. I'm seeing it now, and I'm seeing why I care about this. I was talking to Chen Yu yesterday, and I'm like, this is stupid. You know, why am I wasting time? Why am I wasting time on mediocre ass AMD? But I mean, it's not about AMD. This is actually easier than doing this with NVIDIA. There is more open source code, and the API looks simpler. Okay. So let me tell you like what I'm like seeing. Okay. So we have this code in Tinygrad called schedule. It's in Realize, but here it's called run schedule. So a few things I'm realizing. We can do the graph matching. Okay. Let me try to structure my thoughts. We have this JIT, and I'd almost like to remove the JIT entirely. We construct this graph in lazy.py, but very often in machine learning, you're just constructing the same graph over and over again. Which, like, we could bypass the Python execution environment to do this, and then we wouldn't have to use the JIT. But we shouldn't need to call all of this realize crap if we could figure out how to hash a graph. And I think there's good algorithms to do this. Like, we need like a graph comparison algorithm that says, like, here's your graph, right? Tinygrad's lazy, and it constructs these graphs in a lazy manner. If we could like capture on the graph and say, okay, when you've seen this graph, it corresponds to what? The answer is it corresponds to a command queue in a GPU. We can prepare a command queue in a GPU. This is why this is worth it. Like, I really want to go to the kernel might be good enough. Look, I just wish AMD showed me that they cared. I wish they showed me that they gave a shit. Because, like, if you don't give a shit, why should I? Why do I want to fix your GPUs? Like, why do I can, what you do, if I actually wanted AMD's firmware to improve, and, like, I just, like, it's not even that I want the source code. I just want them to show me that they care. No, you don't need the, okay, so there's different levels of queue. If they were to open source it, they're like, oh, we care, right? I don't want some like verbal platitudes saying that you care, right? I mean, I could ask for money, but that's tacky. I don't want money. Like, show me that you care. Show me that you want this to be better. So the way that you make this better is you write a fuzzer. I could write all sorts of, like, you want to take, Tinygrad can generate a massively diverse set of kernels, and I found them compilable. It's just like, be better, care. Can you get people who care? When there's bugs, when there's bugs and comma shit, I'm so angry. Like, I want them to be better. No, actually showed some words are so worthless, and I fell for words from them. They gave me nothing. Why would I want to, like, how much money is it worth to get AMD on MLPerf? Or do they just think it's worthless? Do they not understand that, like, you're not going to succeed in ML by just pushing your... Sure, you can probably run government scams to push your instant cards into fake government supercomputers that don't do anything. But if you want to actually succeed at ML, it's a boots on the ground strategy. This is how NVIDIA succeeded. NVIDIA worked their way up to where they are. NVIDIA gave me a free computer. NVIDIA gave me a computer with 4 Titan X's in it. This is OG NVIDIA. They cared. I don't know. I mean, NVIDIA got bad after the stock price went up. But do you really blame them? AMD cares about server GPUs. It's the same shit. Yeah. No, I just like NVIDIA deserves to win. I'm not starting down a rabbit hole of Intel Arc. I'm gonna guess that Intel Arc. So your software looks like your organization, and I'm gonna guess Intel Arc looks like 8 people having a meeting with a VP. All right, you gonna tell me to relax again? You're banned from the stream, bro. Saying it once is fine. Saying it 3 times, banned from the stream. The server GPUs all have the same bugs. No, I think they have genuinely no idea. I think that, yeah. No, Intel Arc will never be good. It's not, yeah. TensTorrent will be good. TensTorrent is doing things the right way to be good, to potentially be good someday. What's Snapdragon Elite? No, Jensen deserves to win. They just it makes me mad to think about it. Can this be communicated? No, I'm not. It's not my job to explain this to you. Well, NVIDIA doesn't care. And NVIDIA genuinely, there's nothing I can like AMD doesn't understand the value of this. And I just don't want to do it. You know what I mean? No, NVIDIA genuinely doesn't have to care about this, right? Like most people are, Tinygrad, Tinygrad is actually the best, if you're trying to do multi-GPU AMD training, Tinygrad is hands down the best way to do that. If you're trying to do multi-GPU NVIDIA training, use PyTorch. Like it's way better. No, I'm not explaining, I want to come up with a strategy. I'd like to come up with a strategy that takes value from them and doesn't give them value. Like the NVIDIA strategy actually does take value from them. If you could really get clusters of 4090s, but NVIDIA's gonna, if you could get clusters of 4090s to be competitive, what it would force NVIDIA to do is lower the price of Blackwell. No, NVIDIA doesn't care. And NVIDIA shouldn't care, right? Like this is a different software ecosystem that may bear fruit for, NVIDIA in 3 years, but that's crazy. Why would they lower the price as an alternative? Well, one alternative is their own consumer gaming cards. But yeah, they probably still won't lower the price. They'll probably just further nerf the gaming cards. You know what? I guess to be more concrete, there's just such a sense of mediocrity around AMD, and I feel almost like looking and working with this API, mediocrity will creep into my life. It's very possible NVIDIA kind of stops making gaming cards, which... No, they don't. They don't actually stop making gaming cards. large graph equals GPU command Q. NVIDIA make gaming cards because they don't want AMD having all that revenue. Yeah, I mean that's a really good point. They won't release 650mm square gaming GPUs. Yeah, that's very possible. We'll see. Well, you're right. I mean, there's no reason. If I'm NVIDIA now, I'm like, RDNA 4 is canceled. RDNA 5. Maybe I'll just ship a driver patch to uncap the 4090. All right, Ugandan wrestling. You are the reason we're going back to subscriber only. So a large graph is a GPU command queue, and then like, you know, memory scheduling is totally separate. I spell that right? I always forget if separate has an E or an A. Do you like capture the large graph and run it as a GPU command queue? Each node in the graph has a program. So here about the mediocrity thing, I mean, this is also like, George, why don't you take a more diplomatic approach with AMD? I just can't. Like, I just don't, you know, don't tolerate mediocrity. And yeah, I mean, the code is a lot less. This code's actually written by some people who care, right? This code is, this API is open source. It's probably, who's ever writing like the DRM stuff for the Linux kernel? I mean, like, what a work of art the Linux kernel is. You look at the Linux kernel and you think there's some things janky about it, but like, wow, you know, so much respect. Like the people who are the maintainers of all the different kernel subsystems. It's the most incredible software engineering project in history. You know, like it's written in old style C. It's these people who, again, you know, it's making me reconsider. It's making me reconsider Rust. Yeah, no, many people have contributed to it. It really is the most incredible software engineering project, and it's high quality. When you look at the kernels for these other operating systems, I mean the Windows kernel, oh my god. When you look at like what the Windows kernel's APIs are and how, yeah, Linus gatekeeps, I know. No, I think switching stuff to Rust is good. I think that a lot of the C style in the Linux kernel is, I don't love it. Like I think it's like kind of antiquated. It's like painful to write a lot of this stuff. I think Rust would fix a lot of those problems. And don't like, I mean, Apple just moved to C++, and C++ adds problems. So where is, I'm not like that. They haven't pushed at all really on the compute stuff. I don't know why. The compute stuff, from what I've looked, is like, I think I could write a compute driver. I don't think I could write like a GPU driver. are the names? What are these code names? Navi, yeah, like I never like you look here and it's, why is this not up to date at all? Did just no one update the docs and it's actually up to date? I've seen this. Some guy actually, I saw a blog post from some guy who's Tinygrad to with this. I mean, my idea is to bypass all these drivers though. So I don't want these like the APIs aren't exactly what you want. I want Tinygrad, this is what I was thinking about in the shower. Like I want Tinygrad to take the graph and construct, like I see it, right? Like you have like a GPU command queue, right? And I have all these dispatches. Each dispatch has 2 resources. So each node in the, let's go to the whiteboard. Can everyone see the whiteboard good? We'll put this away. This drive. It's trash. Some trash here. I'm gonna throw this trash away. I'm gonna go to the whiteboard. You know, something I'll never understand about these companies when they have like an open source driver that's way better is why they even bother with their own driver. Like, why don't they just give the documentation and give what open source people want? These things are reverse engineered and better. I don't know that much about, I know a lot about GPUs for compute. I don't really know much about GPUs for like graphics. I never got that into that. Like the kind of people who can tell you like what a vertex shader and a fragment shader are. Like I vaguely know. Okay, so we have like tensors. Right, so this is like tensor 1, tensor 2. We can do something like a mul, right? Do like a sum. And so this is the maybe afterward you do like a ReLU, right? And then this gets stored in TensorFlow, right? So this is a single node. I mean this is a mapmul. This is a convolution. This is anything. So you probably can't see. I've got to find a better marker. This one kind of sucks. You see this marker better? Not really. These are not very good markers. That's better. Okay, so this graph gets shrunk down into just a like, here's your compute node. Right? And your compute node, I mean, where does tensor 1 come from? So we'll have we'll have a compute node here, a compute node here. This edge is tensor 1. This edge is tensor 2. It's all just graphs all the way down. You know, another amazing project that I wish Chris Ladner might have even said LLVM is too confusing for me to understand now. But all projects eventually collapse under the way their own complexity. So yeah, some other compute node uses tensor 3. So this whole thing is this, right? So yeah, you have kind of a graph where the nodes are compute and the edges are tensors. Man. spent a lot of time. I don't know if this is possible, but like, you just see it so much more clearly as you go through this. Like I used to have these things. So there's actually a little. This isn't exactly right. There are movement ops here, but these are just ways. They're just addressing modes for that tensor. And I had like so much complexity around the movement ops, and most of that complexity is now gone. Like the movement ops are now just represented as shape trackers. There no longer are explicit movement ops in the kernel, except in in Tinygrad, except in a movement op is just a way of talking about how this multiply accesses this tensor, like with strides and stuff. And through those strides, you can describe mapples, you can describe convolutions, you can describe everything. Basically, through this, you can describe, like everything you need. Okay. So these are compute. We're now, Quasalin's working on adding support for this, which will have our compute nodes allowed to have multiple outputs, which is cool. So that just makes it a more complete graph. So the edges in this graph are tensors. Maybe it's not just a tensor. It might be a tensor plus a movement op. Yeah, I mean, you need a movement op there. And then if I'm like using tensor 1 somewhere else, I may view tensor 1 in a different way. Yeah, that seems right. Okay, so like that's what your graph looks like. Now, is this visible? Can you guys see? Oh, full cam. Oh, I don't know what I was thinking. You're right. Yeah. So, I should have drawn this more on the other side of the board. Man, it's all just graphs. You get caught up in like nuance of all this stuff, but fundamentally it's all just graphs. And then like, you get like this graph. Okay. So, there's two things that basically get topologically sorted. So this is a graph, but this is a graph of what we call in Tinygrad ops. Ops get lowered to uops. So the difference at op operates on an entire tensor, whereas a uop operates on a register. That's basically the distinction. Ops get lowered to uops. And then uops have to be topologically sorted to go into the compute. So both NVIDIA and AMD GPUs are basically just, they're just processors. Processors have an instruction pointer. The instruction pointer moves through a list of instructions, and yeah, it goes there. So like you can imagine, like it's like load, mul, we have like two loads. A mul, we have an add, we have a loop around this, and then we have a store. Actually, the loop has to include the loads as well, so it's like a loop. All right, so here we have like a, go to 10. 10 is up here, we can get rid of the loop like that. Really, really linearize that shit. So this is what the linearizer does. So the linearizer is a kind of a misnomer now. We're going to write the new linearizer called the lowerer. And the lowerer just lowers ops to uops, but still keeps them in graph format. By the way, did anyone do my define globals thing? Oh, man, okay. Did anyone do my my define globals thing? So there's a little more. You usually have like indexing before your loads too. You have to do like uint 8 indexing, uint 64 indexing, so on and so forth. Okay. No, what am I saying? Sorry, I was just talking about data types. I didn't mean to. Indexing is the expression of the movement ops in terms of like assembly instructions. If you want to do like a stride of 64, you have to take the index and multiply it by 64. It's the same multiply as this. So you end up using pretty much the same ALUs in most of these things. Some of these GPUs have separate streams for integers and floats. But yeah, so you have this gets lowered to this, and then it's a node in this graph. So this is topo sort 1. Okay, so fun definition of what a topological sort is. So let's look at this graph and let's topologically sort it. So the definition of a topological sort is it's a list such that an earlier item in the list, anything that's a child, is always lower in the list. So there's 2 valid topological sorts for this graph. You can do 1, 2, 3, 4, or I can switch 1 and 2, right? There's no reason this has to be 1. This can also just be 2, this can be 1, and we're good, okay? So I'm just thinking about I'm thinking about whether these things are actually graphs or not. They're not exactly graphs because there's like ports on these things. Like these edges are not exactly symmetric. The edges have an order in a node because, so some nodes are unordered. Like it's just commutative nature, right? If A plus B equals B plus A, but A minus B doesn't equal B minus A, so these edges are ordered. So the structure's not exactly a graph, but it's close enough to a graph. Okay, so this is a topological sort, right? Let's talk about what can change in this topological sort. So these 2 loads, there's no reason that they have to be in a certain order. I think everything else has to be. I guess I can move some of the indexing below a load, and the order with which you topologically sort this can say a lot about performance. So eventually I want to have AI search algorithms searching the topological sort there. Okay, now let's get to the next thing. Oh yeah, no, this is good shit, boys. See, what I want to do is I want to stop thinking about it in terms of. What I said to Chen yesterday was like, do we still want non-graph API? So if you look in Tinygrad now, there's this folder in runtimes called graph, and graph can run things like this. But I think we actually only want to support graph. Because you're never going to be running one node. The only time I see you running one node is if you're doing it for benchmarking for Beam, which Beam is a whole other thing. So within this UOP lowering, there's lots of different things you can do. You can choose the order with which you iterate over these things. You can choose the order often matters a lot because of whether you're getting cache hits or not. Like they'll teach you this in any basic computer science class. They'll teach you like a matrix multiply, right? When you usually learn about caches, you learn about matrix multiplies, and you learn why you don't do this times this. The problem with that times that, and then you go that, is it thrashes your cache. So you'll learn the tile-based matrix multiply algorithm, like you map all of these, right? And then you'll do it in tiles, right? So I'll go like this tile, this tile, this tile, right? Multiply those, multiply those, multiply those. And that tile is usually the size of my L1 cache. You can go even larger. You then also want to tile to like an L2 cache, right? You figure out what you eventually store. So cache-aware matrix multiply. If you didn't go to college, watch one of the many nice YouTube videos that explains this concept. So this sort of cache awareness is determined by our UOP lower. And we have this thing in Tinygrad now called beam search that will just, it searches over an optimization space. We have these optimization operations which can determine how this stuff is broken down into this stuff. Okay, so the term Tenstorrent kept using was graph compiler, and it's a smart term. Yeah, I see why they use graph compiler. Okay, so we have to do the same thing here. So this is our compute node. We have to topologically sort these things. So let's just come up with a quick topo sort. 1, 2, 3, 4, 5. 4 and 5 can be switched, 1 and 2 can be switched, but note that 2 and 3 can't be switched because that would violate the topological sort of the graph. So let's come over to this side of the board. We have Q. Okay. Q is 1, 2, 3, 4, 5. 3 has edges back to 1 and 2, so these are dependencies. And 4 has an edge to 3, 5 has an edge to 3. Okay. So yeah, that'll make sense. Let's say 1 and 2 are like creation ops. Okay. So that's a topological sort of that graph. But right now, the data structure that we're using to represent this Q, we have 2 data structures that we use to represent it. So the one that looks like this is schedule item. And actually, you have to go a little bit further than this because you really want to talk about these being outputs. Right, so this outputs 1. Oh, those aren't exactly, those are edges. So it's not exactly right. You gotta be so careful how you define this. Because you gotta think about how it works for multi-output. We're gonna have multi-output in Tinygrad soon. But so we have the type is list schedule item. We're gonna finish this. Like, if you go into Tinygrad, I feel like tensor.py and MLOps and almost now lazy are finished. Like, we're just done. It's beautiful, they're done. We're now kind of there with view.py. There's things in Tinygrad that are just like, there was this concept Erdos would talk about called from the book. Whether Strassling-Legados or arbitrary conventions or are. So Erdos would talk about these proofs being from the book, like that one's from the book. So yeah, like I want to find the code that's from the book. I feel like MLOps, tensor, view are getting close. The linearizer is still a pile of hacks. The scheduler is a pile of hacks. UOPs are a pile of hacks. The runtimes are not expressing the correct thing. Everything else kind of sucks, but lazy.py is now a lot better. And the concept of the scheduler is good now. The concept of the scheduler used to be intertwined with all the crap, and it didn't make any sense. But now it makes sense. Okay. So you have a list schedule item. So what do you lower a list schedule item to? We have something that lowers it to this list JIT item, but that's not exactly right. The problem with JIT items is they are, I mean, it's kind of right. It's almost what you want, but you really just want to make this into a GPU queue. Right? Or maybe another word is just command queue. We won't say GPU. Everyone's trying to go, oh, we've got TPUs, Intel's got XPUs. AMD. It's actually kind of smart of them. AMD, when you install ROCm Torch, you don't do .ROCm, you do .CUDA. How many lawyers had to discuss if that was a trademark violation or not? So yeah, I mean, we should, instead of JIT item, we need to rename that. We need to rename that structure command queue. And then, like, we lower command queue to hardware command queue. Hardware command queues actually execute on the device. So the realization I had in the shower was that you can capture this graph as a hardware command queue. Right? Like, this is kind of where it gets annoying that we're using Python. It's not Python. We need to be just better about not having, all things are all possible in all languages. But it's like, it's functional. See what I mean? Like there's a functional transformation from this graph to a hardware command queue. So as soon as I can recognize that graph using hopefully an iterative hash function, yeah, I can just totally use a hash function. This is a Merkle tree, right? If I do like a Merkle tree, and if I use a cryptographic hash function, it'll never miss. Like it'll never collide. I don't have to fall back to a slow path and deal with like bucketing. If I can find some fast cryptographic hash function to hash lazy as we go, I then just have to do like a key match to a hardware command queue, shove that hardware command queue in. Oh man, then we don't even like need the JIT anymore. I mean, we still want the JIT to avoid the execution of the Python code that builds that graph and does all that hashing. But this will make Tinygrad fast without the hashing. So the other thing that's like kind of stupid in GPUs that I kind of want to get rid of, and you see why TensorFlow did it this way, is the concept of these individual memory allocations. I really don't want to do that anymore. I just want to allocate the whole damn memory. You know, I'm not going to deal with like it shouldn't be. There shouldn't be a concept of multi-process Tinygrad. If we just allocate all the memory, then the hardware command queue includes offsets into the memory, but you're only sort of running one at a time. I'll have to think through that stuff a little bit more. I don't know. Whether we allocate all the RAM or not, it's not actually that big of a deal. We'll have to build these same abstractions anyway, so whatever, we won't actually do that. But it's a cool thing to think about, and we can avoid all the I/O calls. Yeah, I do kind of like allocating all the RAM. The more we can avoid syscalls, the better. We just won't be so proud of it. We'll just write like all the RAM. See what I'm saying? So like you can take the GPU RAM and you can allocate it all. I see why you people think I'm on drugs. I see why. Yeah, maybe, you know. You ever actually see? I mean, it's you know, you see me when I actually take stimulants, I calm down. I don't like act like this. See why you think I'm on drugs. ROCm hardware command queues don't support graphs. You need to use PM4. Yeah, I think that's what we're using. We have some stuff. Like, the only primitive that we need, so it's not actually a graph. The only primitive we need is the ability for one thing to wait on two things. Or multiple things, right? As long as we can put a barrier here that blocks the execution on the completion of 1 and 2, that's the only primitive we need here. And this is why I'm working on these APIs. If we understand what these primitives are, we can push these primitives to higher up in Tinygrad. You have to think of it like, I have these things like load op sync and load op wait before copy, but they're not really right. And Nimblejam is like, can you delete that? And you can almost delete it, but not exactly. You want this idea of like, yeah, you want this idea of this waits on these things. What's a bump allocator? Others may use the same GPU. Fuck others, get off my GPU. It's my GPU, I'm taking all the RAM. Well, I want to avoid, hopefully what we can get the GPU drivers to be is most GPU stuff's accessible in user space. So this is the other reason I'm interested in looking at that. That other crap's making way too many kernel calls. Though I have an idea that you do have to make a kernel call so on NVIDIA, you don't have to make a kernel call to ring the doorbell. On NVIDIA, you can just poke the doorbell memory and you're completely out of the kernel by the time you're even like doing like a CU launch kernel. So on Qualcomm, you push this stuff all to the driver. sorry, not that. You have to push the stuff in the kernel. You have to tell the kernel, hey, run these things. I mean, we can reuse a lot of these primitives through a Qualcomm driver as well. I know I canceled the Qualcomm GPU driver, but I'm realizing now this is more important than I thought. There's a part of me that, like, we want to get to the hardware. What is the hardware? The GPU is just like, it's a pile of RAM and then a command queue executor. And then each one of these nodes in the graph, of course, has assembly, right? This is like assembly. We have this whole like compiler stack that generates the assembly from this. But we can eventually remove the compiler. We can do code generation, allocation, all those fun things. And then you also have to think about how to use the local RAM on the thing. But this is like what this whole paradigm looks like, whether you're using GPUs or GPUs. There's other paradigms that look kind of different, where you kind of lay the graph out on the chip. Cerebus and TensTorrent are thinking more like that. But if your idea is the GPU basically executes one kernel at a time, it looks like this. And yeah, we should rebuild the runtimes to look more like this. Command queue, hardware command queue, and HSA is probably a good place to do it. It's also like, this is less of a waste of time than I thought. I thought I had to spend time working on all the high level, like Tinygrad stuff. I like the linearizer, but my eyes glaze over when I look at the linearizer now. I was never very good at writing linearizer. I'm much better at this stuff. But this is also going to fix, this is how we're going to make like Llama fast. How do you make Llama fast on 6 GPUs? It's not the algorithm, it's this. It's a little bit of algorithm stuff. You think I'm reinventing Vulkan? Yeah, I mean, Vulkan might have these sort of primitives. Again, you stick APIs on top of things. The APIs are right mostly, but not exactly right. Like Vulkan, every time I've looked at Vulkan, I'm like, this thing was designed to be way too flexible. This is... No, you don't want to go into Vulkan. Yeah, I don't think I do. I know nothing about DirectX. I haven't compiled a program on Windows in 10 years. But yeah. So we end up with these command queues, we end up with these programs. It's this graph. It's all just lowering. It's all lowering from a neural network spec down to a hardware command queue that properly executes the stuff. Okay, so to get into how to drag NVIDIA, drag AMD and actually make them good, the way, if you actually want AMD to be good, it's like going on Twitter and demanding they release the firmware. It would be nice to show that they care. If you actually want someone to be good, you give them a failing test. And you give them a test that's hard to make pass. You give them a test that frustrates them and is like, we need to rewrite all this shit. So if I really wanted to, you really want to make AMD good, you write a fuzzer at this level. Don't worry about any of the other crap. You write a fuzzer at this level that uses all sorts of command queues, and then as soon as it detects either a crash or a GPU stall, generates a repeatable example. And then, you know what? Don't even send them the fuzzer. Just send them the examples. You know what? No, see, you want to do it open source, but you really want to do this as a business. You send them 2, and then you say, well, the rest of them are $1,000 each. Like I mentioned yesterday, better scheduling. What, inference? No one cares about inference. We do training, boys. Inference is done a long time ago. Let like TensorRT, compilers like that do inference. Who cares? This is probably kind of what TensorRT is, by the way. You know, NVIDIA has mixed quality too. Like some of the things are very high quality. I was impressed when I found a bug in Nickel how quickly someone responded and we got it fixed. All right, that's kind of like that's everything. That explains to you what Tinygrad is. Tinygrad is a compiler that goes even from higher level shit than that. Tinygrad is a compiler that goes from x.conv to dw.relu. Right? Is this everything that I drew here? Is this one line of Python up here? conv2dw.relu goes to that, goes to that, goes to that. But no, the graph capturing. We'll call it a hash capturing graph. I'm sure there's good papers on this. I just need to read one and implement it. By the way, we're hiring. If someone finds this stuff cool and wants to come work on it, I have many millions of dollars to hire you. Again, what do we really look for in people? A desire for greatness and skills. Like you want things to be great and you have skills. Like if you're on here and you're like, wow, this is actually like, I want to work on this stuff full time, like come work on it. Start by doing bounties. Prove that you can do it. DM me for a job. Don't DM me for a job. Do bounties, right? I wish everything was like this. It's like I'm not gonna like gatekeep. I'm not gonna judge based on how well you can communicate. I'm gonna judge based on how nice your code is. Right? Like you wouldn't believe, you know, just do the job. Do I have remote jobs? If you're asking that question, no. Do I have remote jobs? I mean, yeah, do the fucking bounty, right? Like I'm not gonna. You don't have to show up to my office in San Diego to do the bounty. Do the bounty. You think if you do 5 bounties and then tell me like, look, hire me, pay me, you know, this, give me this equity, and I don't want to work in San Diego, but I'll keep doing this. You think I'm not gonna hire you? Or like you people don't think. You people don't spend a minute and think like, you know, you have no empathy. That's no empathy. But what if you want free money? Rob a bank, bro. You don't even need a gun. Just go into the bank, tell them you have a gun, don't actually bring a gun, and be like, I'm here to rob this bank. Can you give me the money? Right? There we go. Free money. With the ML perf bounties, go do the ML perf bounties. We now support NVIDIA. Our NVIDIA stuff's getting good. I don't know why they just didn't like we should put we're gonna put more effort into NVIDIA and make NVIDIA faster. I gotta get some boxes up real soon. But you can also rent them on Vast AI. We are focusing on speed on NVIDIA so normal people can use this shit. No one has a 6 GPU AMD system and no one should buy one. You're still lamenting your 7900 XTX purchase. I am sorry. I apologize on behalf of AMD for their software being shit. Do I care about college degrees? You just got banned. You actually just got banned. You just got banned. You pay no attention at all. You were also saying something about me being smart and then caring about college degrees. You showed me that you are dumb. All right, too mean. We're not being mean here. Like, is that person trolling or is that person serious? I don't care if he's 16. This is the beauty, you know, on the internet, no one knows if you're a dog. Saying I'm 16, you know what I love? There's a thing on 4chan where it's like, the phrase tits are GTFO. is a phenomenal phrase, and people think tits or GTFO is misogynistic, and I will give an argument for why it is not misogynistic at all, and actually a true expression of equality and meritocracy. So the phrase tits or GTFO only comes up when someone claims to be female. The thing about claiming to be female on 4chan is you do not actually have to be female to do it. Alternatively, you could be female and not claim it. On 4chan, everyone is anonymous. But if you are saying, hi, I am female, I am feminine, tits or GTFO, right? You are asking for special treatment, and in exchange, we would like to see some tits, right? Is that fair? Is that fair? I think that's fair, right? Because it's not about who you are. It's not misogynistic. This isn't about women or men. This is about you claiming that you're special. And saying you're 16 is the exact same thing. Is there a difference between trolling and being serious for trolls? The only difference is the mental state, and you can't think about the mental state, right? Like what's the difference between someone who's just an idiot and a troll? The troll might actually be smart and just be trying to provoke and agitate. The idiot is just an idiot. The difference between a troll and an idiot is an idiot will never get better, a troll might. All right. Wow. Good rant. Tits or GTFO? Oh, now we have all these wonderful ideas, and now we come back here and the map returns -1. We need food. Where's my phone? Folding phone. Folding phone. Where's my folding phone? It folds. It's phone. It's a folding phone. Oh, change cam view. Good point. Sorry. I need an operator. I need a stream operator. Exactly what part of AMD software sucks? The firmware. The out of order schedule queue. So yeah, you know what? They still say they're going to open source some stuff, and I'll believe it when I see it. AMD can earn respect. Does AMD want to earn respect? Open source their shit. Put out a blog post that says, we want to be better, and we are taking concrete action toward being better by open sourcing and documenting our shit. Wow, is that so hard? We want to be better. Just imagine that. Imagine they published a blog post that said, we understand our drivers suck balls and have sucked balls for 15 years. But today we are making changes to make them better. These are concrete changes. These are not just empty words. We are open sourcing this stuff. We are documenting this stuff. We're putting bounties out for bugs. Wow. They could turn it around. Are there going to be T-flop bounties on the... Yeah, I think we do some T-flop bounties on that. Why am I paying out bounties to make AMD shit better? Why am I doing that? Not anymore. Delete those bounties. Well, those bounties are fine, but like... What kind of food do we want? Definitely don't want Shanxi Magic Kitchen again. I want breakfast. Or will I feel good after I eat? Oh, Havana Grill. 59-cent delivery fee, sweet. Let's get some vodka Frida and some sweet plantains. Sounds good. No, but like it won't happen, right? And live for the moment. That takes too much pride. No, I don't know if it's hard for them to open the drivers. I think that they're just like, I look back at their communication with me and all I see is kind of like they're engaging emotionally and not technically. Right? Like the kind of person who like, we understand your frustrations. Nothing more is like more, when you actually start to look at this phrase, a lot of people will use it and then you like realize how much infuriates you. Like imagine you're standing at a checkout, right? And you have all your stuff on the counter, and the person's just sitting there on their phone, and they're not scanning any of your stuff, right? They're sitting there on your phone, and you're sitting there, and you're like, excuse me, could you start scanning my stuff? And they're like, yeah, I understand your frustration. Yeah, I'd be frustrated too. I understand. I see where you're coming from. I really get it. Like if I was like at a grocery store and like someone was waiting to check me out and the clerk was just sitting on their phone, yeah, I'd be frustrated too. I really get where you're coming from. I really empathize with you. And you just like you look at this person. You're like, no, put your fucking phone down and start scanning my shit. Yeah, which is just like it's worse. It's like, would you rather that checkout person just stand there and like not do anything? AMD, we hear you. You don't hear me, right? Like I think it's rude to like quote from people's emails or post people's emails, but like you see phrases like that and you're like, no, you don't understand what I'm saying at all. AMD needs to implement self-checkout. Exactly. That's what I'm saying. How do we make change? How are we going to make change? Answer, we're not. Oh, the government involved for backdoor. See, that's kind of what, I mean, we could start, like there's an aggressive strategy here. The aggressive strategy is to like look through and figure out what patents they're infringing. Right? Like you could do that. You could find exploits. You could look through. You could break their PSP, right? Like you could do all the things that like, just like open source the firmware, and we wouldn't have to do any of these things. Right? That's like an aggressive strategy. I mean, not like a blackmail kind of way. Just in like well, this is what we're doing now. I choose to spend my time doing security research on AMD. What if someone leaks it? You don't want to do that. The problem with leaking things is like it's not usable by any like the Linux driver people aren't going to look at leaked sources. Yeah, so that's not a solution, unfortunately. It's also illegal for you to do that, so don't do it. We don't encourage illegal activity. We used to end every stream with "Don't kill anybody." Don't leak any internal shit either. AMD's PR manager understands your frustration and has no idea what you're saying. Yeah, that's a good way to describe it. Well, I mean, there's a difference also between like looking at leaks and Ice Leo, welcome. There's a difference between looking at leaks and like encouraging leaks and doing leaks, right? Looking at leaks, I mean, again, if you're trying to like be legitimate, don't do that. If you're trying to just like, fuck around, whatever. Some leaks are interesting to read. How do you think I know things about the Windows kernel, right? That said, I'm talking about companies here because we respect companies. The government works for us, so if you're leaking shit in the government, well, that's a whole different story. What's very GPU? Oh, this guy's writing a. Implement a HIP API? Why are you doing that? Don't implement a HIP API. That concerns me about your project right now. Does this thing work though? Pretty cool. Oh. Hasn't been updated in years. Wait, he also wrote coriander? Was this a fork? I mean, the problem with targeting hip is like, what do you mean by hip? Is that also your, wait. Hmm. Very cool. I think I judged too quickly about the hip thing. Few core operations critical to ML. Don't do 10H. Here. You want all the operations critical to ML? exp2, log2, sine, and square root are all you need. Where do I use sine? Just in sine. But actually, wait, do I do that in... TANH uses sigmoid. Sigmoid doesn't use sine. Look at the code for sigmoid here. Sigmoid is just exp. Sine is stupid. Do we really need sine? I think there's like a Taylor series approximation for sine. This is I like this paper. It's like goes into all the amperes. So there's mufu here. Is there a sine instruction? Oh, there is a sine instruction. There's a mufu cosine. The mufu supports TANH. You know, we might want to add more more ops. So the MUFU is NVIDIA's multifunction unit. It's interesting the ones that they have here. We don't need F64 shit. Randan? What about Randan? Oh, we use sine for Randan? Oh, we use sine. We'll use cosine anyway. Okay, never mind, we need sine. You know, the more I'm thinking about what our chip's gonna look like, the more I think it's just gonna look like a, like the first version of the chip just looks like uops. So we have a lower level called uops. So these are ops, and then these are the uops. A bunch of like, but it's like the simplest assembly language I've seen. We have to get better also. Not all the devices support all the types, and we have to be better about not supporting types. Bool is super annoying. Bool caused all sorts of problems. WebGPU, that was one of the reasons we had to remove WebGPU. There were all these hacks around the code for Bool. Does this have warps? Remember that time I wrote a RISC-V core? RISC. Oh, where's my, that's not it. Your CPU dot, oh, that's the Python version. Yeah, there you go. There's a CPU in Verilog. I didn't write any like dispatch or anything. I wrote just like real simple crap. So I'll think about it once it starts to look more like a GPU. I mean, you need warps basically. Man, I kind of feel like what we're going to make looks like a GPU. We'll have to also build, there's so much work to do before we can actually do this. Like, so much work. Remember when I was writing the cherry stuff and I thought like I was somewhat close to something? All right, we're gonna want to basically build a GPU with tensor cores. We're gonna want to get a simulation environment working. Bring Cherry back. Where is Cherry? I was so naive. People make fun of me for like being naive about stuff like that. Yeah, of course, if you know about things, you're it looks dumb, right? But like, this is how you start. thought this was much closer than it is. We're oh, this is when I was writing the RISC-V core. 10. Oh, this is yeah. I got a bunch of friends who've taped out chips too, who could definitely help me. We sell cards. We sell cards. We sell a version of the Tinybox that has a whole lot of them in it. So naive. So naive. With nickel style primitives. You don't need nickel style primitives. You don't need any of this stuff. I think it's like 5 million to tape out a 12 nanometer node. We can raise for that. We can raise it I mean, if we actually get to the point where we're doing a tape out like that, I'll raise a 500 million. Our last comma round was 500 million. Yeah, maybe that could be our next round for Tiny. Once we get to that point, we raised 5 on 50 for the first round. Yeah, we'll raise 50 on 500. We'll do some chip tape outs. Can't believe I thought I'd flip the company. Seeing Very GPU. Thank you for linking Very GPU. Thank you for linking Very GPU. You've given me hope that I can actually that we can do this in a reasonable time. How do I win against the other custom chip people? By having software that works. Those are the last people I'm worried about. The question is, how do you win against NVIDIA? You don't control the whole process end to end. Does anyone in here know, will I be able to tolerate working with TSMC? Like, I'm not able of tolerating working with AMD. Will I be able, I'm disabling subscriber only in case someone actually knows, but the minute an idiot talks, we're just putting subscriber only back. Jesus. Backslash. Hello. Never mind. My guess is that all big corpos work the same. I mean, like, no, look, I have no problem walking into the Apple store and purchasing a, TSMC should do what you need if you've got the money, but expect anything you do to be copied. You're not that worried about that. What do you mean copied? Like, TSMC is not going to run off. Yeah, they're not going to run off other chips. They might designs. I'm not worried about that. If they were running off knockoff versions of my chip, I'd be pissed. But like, no, TSMC does not do that. That's so stupid. That no company like that would ever do that. No, they wouldn't. They're not Chinese. Even the Chinese mostly wouldn't do that. And the Chinese might, give it to the government, but TSMC is Taiwanese. They're not gonna do I just did a bike trip around Taiwan. Like, Taiwan is like a first world IP respecting democracy. They're not. Ooh, Taiwan is not China. We're really getting spicy here. No, I'm not worried about that. Intel Foundry Service? No. You want to have 8 people talk with a VP? No. I'm sorry to pick on that guy too. I think he was trolling, but if he wasn't trolling, some deep questions about your culture. No, look, I knew someone who worked at Intel is. I heard a story about Intel having a contract to change light bulbs, and it was $300 a light bulb. Just buy a lithography machine, okay. You probably still get a price from Intel. Yeah, how many jerk-off meetings do I have to be in before they give me a price? No, we can tape out a 12 nanometer chip. I think that's totally within our abilities. No, I don't think it'd be the same order with TSMC. Also need to talk to Cadence, Synopsys. Do I need to talk to them, or do I need to just like pay them, 50 racks or 500 racks for their software? I don't know, we're so far away from taping out a chip, guys. Can't even get a price without talking to them. I hate that. No, we're years away from taping out a chip. But I do think our chip is going to look more like a GPU. We have to remember that nobody is touching NVIDIA right now. It does not require a radical rethink of the architecture. Maybe just a clean room design that copies the best things from GPUs is good. Just buy another startup that already has the relationships. Look, I don't want to participate in this world, right? We'll get a chip taped out. We'll figure out how to do it, and we'll figure out how to do it without participating in scams. The fuck is a partnership? I have a partnership. In high school when someone's like, "Yeah, I hooked up with her last weekend," right? What did you do? Did you have sex with her? Well, no, we drove to Dairy Queen and sat in the bed of her truck and ate ice cream. Oh, yeah, you hooked up with her. I got you. So I hate the word partnership, and I never want to see it. I have no idea what it means. It is some business version of hooked up. Find a startup that you can tolerate working with. Again, I'm joining NVIDIA, guys. We're gonna beat NVIDIA. It just might involve using NVIDIA on the way. I did go my own route with pick and place. Yes, yes, I did cut out all of the. You know what it is? These people just don't desire greatness. By the way, the comma 3x failure rate is 1%, because we desire greatness. I bought the best pick and place machine I could, and TensTorrent had an opportunity. TensTorrent had an opportunity for us to write their software. They turned it down. Burning down NVIDIA? Come on. We love NVIDIA, guys. We love NVIDIA. You know what it is? They might be price gouging, but we have to respect greatness. The world really just needs more respect for greatness. A lot of people seem okay with big VRAM and some okay cores. I don't think that this is the future. I think that there's That might be fine for batch size 1 LLMs. No, come on. Like, how much respect? You watch that B200 and you're just like it's just a challenge to the world. He holds that chip out and it's just like, come at me, bro. You know, we gotta respect. We gotta respect NVIDIA. Oh, beating CUDA's easy. CUDA's not good. Like it's just like kind of not broken. I want to see 1592. Okay. All right, back to work. Go to the bathroom, then we'll go back to work. We're gonna take out a GPU. We're gonna make our own GPU. We're gonna get to the bottom of the most minimum thing. We're gonna build a simulator for it. We're gonna figure out, we're gonna run the simulator on all our workloads, and we're gonna tape out a GPU. Let's go. This was always the plan. It just takes forever. Everything takes forever. I'll say one more thing. Should we sell red tiny boxes too? Should we sell red and green? We'll start with green. It's possible we'll sell red, and we'll put a big warning on the red box. We'll put a big warning saying may have unfixable driver issues. We'll get like one of them stickers. We'll get like one of them stickers that says may have unfixable driving issues. Did I get green pre-orders? I'm just gonna ask all the pre-order people like what they want. Looking for big skillers, looking ridiculous, blue and red, like I don't see what the big deal is. Double barrel 12 gauge, bigger than Chris Wallace. Get pissed because Biggie and Pac just missed all this. So it won't lead to issues going through the roof, yes. My food. To get rampant. Getting rampant with this hard. Okay, so we're allocating memory. Let me. It's pretty minimal already. We don't need S-trace, I don't think. Oops, without guard pages. Should clean this code up a bit. Create events. Here we go. Create queue. I think that's what we have to do next. So let's create a queue. Maps memory to GPU. We might have to get there. What are my queue options? Oh, it's not what I want to look at. I want to look at the actual file. Oh, guys, we're gonna tape out. We're gonna tape out. We're gonna tape out chips. Towards a transformative hermeneutics of GPUs. No, there's only one way to win. There's only one way to win, and it's someday I'll own a fab. Then I'll have to deal with the people who make the fab equipment. Someday I'll make my own fab equipment. Where does it stop? Some things are okay to buy. If I can buy it on Amazon, I'm fine with that. The part is when things lock up. Well, you can read that. You can read the high quality while we switch the queue to out of order. Someday I'll make my own atoms. No, it's a process. It's just a process. Oh. You know my dream. To build a self-replicating robot. KFD, we pass in the ring base address. So where does that address come from? The allocated memory that had flags 004. User pointer? What's user pointer? Do we have to allocate memory for the ring buffer? I don't know, but is this has to be GPU memory. Write pointer address, read pointer address? Why are they just like random? Oh. I don't know. Single cadence sheet license is $500K a year. I mean, that's fine. Well, like I said, we're going to spend... It's going to cost like $5 million to tape out the chip. We just accept that. Is there any open source stuff? We're so far away from this. It's like people who've done it for like really oh, tiny tape out. Oh, this is actually a thing. I've seen this before. What process node are they on? This is very cool. Who's ever doing this? Fabless. Okay, so Skywater 130 nanometer open source PDK. Six-month lead time. And it looks like FPGA kind of stuff. Open Road. Funded by DARPA. Wow, why don't they give the money to these people instead of Intel? Oh. They're nearby. Oh, God, I've seen stuff before. Wait. Wait, really? It might be possible to work with global founders too. That's interesting. I mean, that's interesting that that's how they price it. So part of the problem also comes into like what sort of memory controllers you can get. Oh, the 7 nanometer open road is not a real node. Okay. Okay, we have such a long road to go. Like, until we have FPGAs, there's not even a point to thinking about a tape out. FPGAs are so fun, though. The open tooling's getting kind of good. Tinybox FPGA edition. Doesn't matter what we're going for. We still need hardware command queues. It's all about scheduling. We need software that can schedule things better than other people. Scheduling is NP hard. $8 and I get 3 plantains? Let me call for white buddy. Compile a model of FPGAs. Well, you gotta be very careful how you do that. There's open tooling for low spec FPGAs. By GPU scale. Yeah, I can have like less compute units, but that's fine. Let's see what a modern Xylophone board looks like. Oh, we don't even need that. What are the good ones here? These things. How crappy is that RAM? Well, like, I want an FPGA board that has some like decent RAM. I have one over in my box. I can go look at it. Does someone got a good one? Oh, bravado? No. So you do it without bravado. Oh, it smells great. What did I use last time? I probably didn't document it. Oh, I used Yosis, a next pointer. Really? What's the best? What's the best? What do you mean? It works on Ultra Scale Plus. ICE 40 or ECP 5? Wait, no, the ICE 40 is like that crappy little one, right? No. There's better stuff than that. No, I used a better one. What's Ultra Scale Plus? You know what upsets me? You know who owns Xilinx? Crappy DDR4. That's fast block RAM, sure. You want to get one? I got one in this closet. Where'd the FPGA board go? Don't know. Ultra screen is only partially open. What's the best RAM I can get on one of these? No, there's DDR3. The hell is this crap? Wait, what? It's an ultra scale? Is that DDR4? Well, if the 4090 is best you can get unless you're buying an A100 and H100. Or if you want maybe an AMD one. But yeah, it's the best consumer GPU. Yeah. Per dollar, no. Per dollar, the 7900 XCX is better. Okay, where can I buy these things? What has one in it? That's actually very cheap. Is this an FPGA or not? Wait, that looks fire. Do they have PCIe? We don't technically need PCIe. We could do everything over network. Okay, so there's a 144 bit. There's like cheap ways to buy these cards. I know there are. That looks kind of good. How much does that cost? What am I connecting? An IDE drive? Oh, look at this. I mean, it doesn't have a ton of PCIe. It would be nice if it had more. Oh, that's just that same SOM. That one is a little bit more. It's a little wider. Yeah, it all looks like the same SOM. The more AMD you buy, the more angry you are. And this looks like the company. PCIe 3.0, is that 8X? We could, oh, is that all RAM? That looks pretty cool. We could probably get a decent GPU on this. Ooh, luxury package. Check out this company. I like that they have things on eBay. Are you Chinese? I trust you Chinese. Where's this company? Wow, hiring 10 people. See. I mean, the problem with this is it's cool that it has HBM and stuff, but I don't think we're going to get any sort of open tool chain for this. It does seem kind of powerful though. Wow, that any of these people took blockchain seriously. No, I mean, I just trust this company. What we found at Comma is we prefer working with Chinese companies because they don't like jerk you around. They don't jerk you around. Like, they're not going to waste your time just to waste your time. They might like exaggerate things a little bit, but everyone does that. Oh, SSD need to buy. PCI Gen 3 X5. Did you end up using Unisoc? No. Let's stick with A45s. Oh, there's Kintex Ultrascale and Ardix Ultrascale. Oh, PCIe 316, whole fat chunk of DDR4, 80 gigabyte, 80-bit bus. So for comparison to like the 4090 is 384. So it's 4.8 times slower than a 4090. Oh, this is exactly the card I was thinking of, actually. The squirrel card. Actually, I heard you can get these very cheap, too. a guy who knows a lot about this stuff. When we're ready for FPGAs, ooh, Altera, an Intel company. PCIe Gen 5? This shit actually works? Acronix. When it's time, we'll find the right FPGA. You're working on a RISC-V core that can run Tinygrad. So, yeah, I mean, I think that's the basic idea. Our core would probably be, I mean, RISC-V probably makes sense. Like, it's not too much more transistors to put the extra, to put like all the ops on there. But only some of the stuff would be accelerated through the vector accelerator and stuff. I mean, yeah, but it's not a lot of, the scaler can do everything. It's all about scheduling. Warps, global sizes, local sizes. Yeah, we're going to take all the GPU paradigm stuff. Just build a good one. You need branches. You think you don't need branches, but you need branches. Okay, let's create a queue. Ring base address goes in. Ring size goes in. GPU ID goes in. Queue type. Ah. Why is this not in? Should be in here. Yeah. Oh, it's not KIO. What did I import it as? KFD. Set the queue type. Queue percentage. I don't know what that is. What's QID? Wow, what is any of that stuff? Oh, I get a QID. Failed to look up W pointer bow. Oh. You know, here's a fun thing too. If there's any exploits in this, we can there probably aren't exploits. This is mainline Linux code. Bit serial RISC-V. We didn't find any exploits. Finding exploits is a long process that involves months of research into a platform. It's only when you fully understand how to use something do you understand how to misuse it. Okay. Wait, none of those things are being passed in. Oh, it doesn't like my right pointer address as an input or an output? Doorbell offset? From. Okay. Why is this not creating? Fail to look up W pointer bow. No W pointer. Why? We might have to map the memory to the GPU. I doubt it, but maybe that fixes it. No. Oh, it's probably our flags are wrong. I don't know what a user pointer is, but let's try allocating one. Yeah, well, that just doesn't allocate. I think it's because it said something about how the API was different if I was doing user pointer. mmap offset 2 KFD. User pointer. Let's see. Is the mmap that fails or no? It's the allocate memory that fails. Alright, so here's where we create the queue. Oh wait, that's different flags. This is where we create that queue. This, interesting, wait a second. Look at this. This is somehow ending up here as the right pointer address. But I don't think I'm putting that in. It says it's an output. The ring memory is a different kind of memory though. Which kind of memory is that? It's GTT memory. Okay, we have to understand what these acronyms mean. What's GTT? Graphical translation table. GPU accessible system memory. Oh. Well, you can apparently disable GTT. Oh. GTT is system memory that can be accessed by the GPU. Does that work to allocate that? Okay, it allocates. It doesn't create the queue, but it allocates. User pointer, on the other hand, doesn't allocate. You can't make your own physics and you can't make your own math. Everything else is negotiable. See how that interacts with that. Oh, okay, it's just mapping normal memory, I see. Let's try that. map private, map fixed. I don't think we have to do that. I think we just map private, map anonymous. There's our other call to our map down there. Do this. Let's just try this. And that just might have been fine the whole time too. No, not that. Okay, it doesn't work. Bind mem to Numa. Okay, that's the bind shit. We don't care about that. But here, so this works. I don't know what this mmap offset is. Where does this come from? Because I do think I have to put it in if I'm doing user pointer. Oh, failed to get user pages, 14. Wait, huh? I don't really get it. What if I just put address in there? Okay, that worked. It just didn't remap it, which is fine. I don't care about that. Because I already have it mapped up here. Like remapping, that's not going to work. Address is not defined. Okay, good. We're allocating a queue memory now. We're still failing to look up the W pointer bow. Which makes me think they're not actually... Let's find this in the... Oh, let's just put some crap in the W pointer. Q are W pointers. Oh. Wait, it like went further that time. I don't think those are... Why does it say... Is that just wrong? I'm not reading it wrong, right? It says that those are outputs, but that doesn't make sense. From KFD. I don't think that's right. Let's read this. No, the hardware is fine. I just wish they'd be open source, and I wish they'd care. Yeah, it sure looks like it's input. Okay, those might just be wrong then. Whatever. Let's read the HSA and see what we get there in Tinygrad. Is this, we can read the driver. So we create queue. No, this allocates all the memory too. No, the lock. Do you know how long it would take to break that lock? Not actually long. It's not the lock. So I'm documenting. Breaking the lock would take a couple days. Documenting it all would take months. run this again, and then let's take a look at the Q shed. Q read pointer, Q write pointer. Very cool. All right. Let's go here. Failed to look up. Again, it's failed to look up W pointer BO. Is that because it's the wrong kind of memory? We need that kind of memory? No, that didn't change anything. Okay, W pointer mapping. So we look at the right pointer address and we see, oh, do we have to map it to the GPU? Maybe that's what it's trying to look it up. Is this the one I want to remap or no? That gets deleted, that gets deleted, those things. It's interesting that that remaps if I do the flags of the guard. Okay, map memory to GPU. Aha! Okay, good. That makes a lot of sense. So we didn't map the memory to the GPU. Ring base address, right pointer address. Yeah, I know it's right pointer. Cool. And we can even write to that memory too. So what is user pointer? Also don't do that. We've created a queue. Who thinks it's talking to the MES? The AMD user space driver is open source, but it sucks. No, I mean, it's not really that the user space driver sucks. It's not that the HSA stuff sucks. It's that we don't really have control over what these things are. And without control over what these things are, it's hard to make things... I mean, yeah, you can say the driver sucks. It's fine. It's just not performant. In order to get these things to be performant, you have to like pre-allocate everything. Is the command queue documented? Yeah, the command queue is documented. It's the same command queue that HSA is currently using, so we can go use that. I don't know exactly how these ring buffers work. They force water to avoid dead. Okay. There's a lot of work to do here. So there's multiple queue types: compute SDMA, compute AQL. Are we creating compute AQL queue? Oh, queue type is 1. Oh, that's an SDMA queue. Oh, we're creating compute AQL queues, which makes sense. I'm not sure what a compute queue is. So we can put AQL packets in. Oh, is one of these where we put in PM4 packets and one of them where we put in AQL packets? So this is our HSA driver in Tinygrad. Seems like the insights gained by making a compact version of this driver would be very efficient, useful to figure out why the firmware crashes. It would. The problem is without knowing exactly like how we're putting things into the queue, it's really hard to figure out anything about the firmware crashes. But what you mostly want to do is write your own version of the driver, and then every time it crashes, like maybe you can log what you did, or maybe you can just write a fuzzer. Again, why am I fixing this? I'm not. Like, we're not really trying to... They work well enough that we'll be able to test this. And maybe someday if we like... How about this? If we go a month without seeing a driver crash on any of our AMD machines, a month is aggressive. Let's say if we manage to go a week without seeing a driver crash on like some new version, then we can ship Red Tinybox. Like we want to make sure what's an acceptable amount. They don't crash. What's an acceptable amount for? Thank you for subscribing. 3 months in advance. What's an acceptable amount for your training jobs to crash? Can it automatically restart on crash? Well, you can write that logic. The NVIDIA number. I mean, you can't just say the NVIDIA number. Can it automatically restart? From what I've seen with the AMD GPU crashes, 1 in 10 will bring down the system. 9 out of 10 just resets the GPU, and you can just rerun the thing. What's an acceptable number? What number should we feel okay shipping the Red Tinybox? %90 uptime. I mean, the Tinybox is sold to ML researchers who just want it to work. Not people who should be tinkering with GPU drivers, no. 10 days without system crash. Yeah, that seems pretty good. No, we don't do Watchdog and once a week. All right. If we go a week and we feel good that it's going to be another week, we didn't say, oh, damn, we got really lucky that week, then we can think about shipping Red Tinybox. Okay, cues are real. Signals are somehow real. AMD Ioctl create FD. Why would you as a customer choose red over green? Save $10,000. We're launching green first. We're definitely launching green first. Wait, oh, did I just get 2 KFD? Did I get to and from backwards? No, that's from KFD. No, that's right. Would it be competitive at 25K? I mean, you saw another person selling something similar for 35K, so yeah. Oh, no, not one GPU reset a day. No, you don't want one GPU reset a day. GPU reset brings your whole job down. No, I want to even say, I want a week with no GPU resets across all our AMD Tinyboxes. If there's even one GPU reset, that's one too many. AQLQ, man. Why is that special? Interesting. Okay, events are real. Creating an HDMA queue there. We test set events, wait events, set events. Oh, events pointers like in userspace. Okay, that's pretty good. Let's take a look at what we're actually going to put on these queues. So this is an HSA kernel dispatch packet. Submit packets. I don't think those things are real. Yeah, I think also like, yeah, this is not... This is virtual AQLQs. We wait on all these signals. That's not really what we want. Completion signal. What's an HSA submit barrier? Okay, so I mean I've looked at this stuff before. So there's these. Okay, we're gonna need this HSA stuff no matter what to get these things. So we have a kernel dispatch. And we have an AND packet. Oh, there's an OR packet too, which is kind of cool. But yeah, so we're going to basically... The AND packet is exactly the... That's like the wait event that I'm talking about. Like that'll become a wait in Tinygrad. looks simple enough. We can do SaaS level stuff as well. I'm kind of interested in that. But no, I'm more interested in scheduling for now. Like micro optimizations are the last thing we do, like SaaS. PTX is fine. Though I wouldn't mind our PTX being made. Our PTX backend should generate better code than our CUDA backend. If someone's interested in improving that, we have a. Where's my compare speed CUDA PTX? I love how things just work. Yeah, so you see that some of these are getting bad ratios, and I want to like look into why. So then you can just take, which one here is bad? That's a pretty slow kernel to begin with. Yeah, that one's terrible. Why is that one 14x slower? What are we doing wrong? So I can say like num equals 105. Yeah, and then, so the generated, oh, this is just like some load fusion issue, okay? Oh, this might be const reordering. So you can look at this kernel is 14x slower. If someone wants to look into like this kernel specifically, you should do it. Figure out why that one's slower, because like most of them are faster. Some of them are way faster. But then you'll occasionally hit one that's 15x slower. That one's 2x slower. It's probably only a few things too. I bet with like a few fixes, our PTX can be consistently faster than our CUDA. What's wrong here? Our code is shorter. Oh, probably like some casting we did badly. No, it looks like there's a lot of problems also around the loads in the integer engine. See how it does over time. Oh, see, now it's slower. Ice Leo, thank you for gifting subs today. Ice Leo is our #1 sub gifter on this stream. It works out to be about the same. But yeah, every one of those that's repeatedly slow, if someone would like to look into this, we would appreciate you. And it's a good way to contribute to Tinygrad. I know I'm one of those people who just gets obsessed with like driving a metric down. Beam search does not take into account prior and future kernels. It's all single kernel optimizations. We don't even have it clearing the cache. Which reminds me, that's another thing I should look at. So Nimmelgen got PM4 clearing packets working. But where is a PM4 packet submitted? Submit PM4 IB. Submit packet. Oh, it's AQL. Okay. Oh. It's like some secret garbage. Okay, whatever. I don't know why it's not there. But can you submit it to the same... It looks like you can submit it to the same AQL queue. No, Intel seems like the only thing Intel has going for them is how cheap the A770 is. It's probably subsidized. They probably lose money with everyone you buy. Like, they fit 16 gigs of RAM on a $300 card. That's pretty crazy. Intel is friends with Biden, exactly. Don't worry. They lose money, but they just get billions of dollars from the government. Whenever a company takes money from the government, they usually end up becoming worse. I mean, and think about why. You just get addicted to free money. Did we get anywhere with a neural network predicting speed up? No, not at all. That was a huge flop. The big advantage that Beam Search got was adding, we added parallel Beam Search. So it could Beam Search across, it could compile on all 32 cores at once, letting us check 10x more kernels. So don't make a smarter search, just make your dumb search faster. Guys, it goes all the way to the top. For however much we think, we think AMD, what we think about AMD, the government is way worse. I've had some interactions with some government people that are like, okay, look, there's people who are content to live in mediocrity. And whatever, you can't really help them. Then there's people who like actively work to make the world worse. Yeah, a very bitter lesson. I mean, yeah, stop trying to be smart, just use more search. Can someone explain in what way one kernel can be better than another? I mean, like, explain how one person can be better than another. It's the same thing. Some people work faster. Some people work better. Some people use less power. What about the not my problem people? Let's not go off on this tangent. Captain Oano, it's because you didn't install CUDA correctly. Do you have CUDA? Sorry. By the way, install CUDA correctly, and then, if you really want to be a mensch, uninstall CUDA and add a decent error message that doesn't say has no attribute mvrtc create program and says install CUDA, you blockhead. Could you run Beam Search on an FPGA? I'm going to interpret what you mean by that charitably and say, will our FPGA GPU support Beam Search? Yes. A good first issue would be, yes, a more usable error message for that. It's a trash error message. Okay, so these are the packets we're going to create. Oh God, we have so much work to do here. We have so much work to do here. You missed the live PR reviews? Let's see what we got today. Oh, we had minimal flag. Wait. What? What? Oh, you disabled the cache. Oh, that's cool. No, we definitely don't need any of that crap. That's cool. My only concern is you check, you check the version. You check the version in the constructor. See, this is a good PR. He even creates this in the constructor instead of having to create it every time. This is a good quality PR. He thought about checking the version. He only adds it if it's the right version. He speeds things up by pre-creating that and improves that to that. Though actually, you should also do this. There's no reason not to do that up there as well, but whatever. No, that would actually probably make the code less readable. So I think this is a phenomenal PR, and Sescatini, we appreciate you. Vulkan backend via compute. Yeah, we're not going to merge this. We're definitely not going to merge this. If you're having fun writing it, enjoy, but we're not merging this. Onyx float compatibility. Okay, so a classic George Hotz stand PR, which includes 17 million commits. Good thing CI is free. Looks shorter. Buffer parse. Yeah, this code looks better than what we had. I'm confident we have good tests on Onyx. I think this is why George Hotz stand likes it. Half to float to half. A decorator. Interesting. Whoa. It's enabling more stuff? That's cool. I mean, it even enables the one called really slow, but still, that's cool. And adds better checking to this. Very good. All right, good start here. Good start here. Tensor Core PTX. Yeah, we definitely need this. Though... Okay, no, if getenv PTX, that's good. No, this is well, this might be okay for the flops here. Yeah, why is the type ignore? That's a good question. I think it could be tighter. I think this is pretty good, but I think it could be tighter. I think like in general, when I see a PR, this is like, and you know what? Maybe this is a draft PR. Oh yes, definitely add it to benchmark. But like this is equals, and this is like when I see things like this, I'm like, eesh, why is the spacing different? That's why we don't use deterministic linters. Okay, PTX cleanup. Why are there new childless UOPs? I'm sketched out by that. This one, I gave them some feedback. Yeah, what are you? No. What are you doing? You want random numbers? You can just put them there. Why don't? This is what? Why is this? No. This is bad code. This is terrible. Like look at that. Look at that copy past to shit. Needs a lot of work. My code. So it's correct, but it's wrong for various other reasons. We have to filter out a sign, and this is what started me on a lot of this scheduler stuff. So I should be better about marking my PRs as draft. Include negative float in test D type. Converting negative float to unsigned integer is undefined? What the hell? I believe you. These kernels needed new instructions. Oh. Quaslin's been maintaining RMU. Just another great favor we did for AMD, which was we wrote them an RDNA3 emulator that we use to test our stuff. You know, what's the problem with compute? I don't know what it is. You can use that to find compiler issues. Or do they have an RDNA3 emulator? Like, why don't they release it? Let's see. Remove requires grad check for replace and assign. Yeah. All the optimizer tests are failing when they use assign. So this guy removed these assert require grad stuff. I don't care about replace. Someone should really add an underscore in front of replace. Does someone want to add an underscore in front of replace? Because replace should never be used by the user. If someone wants to do a PR where they replace with an underscore in front of it, I would merge that. Because no one should be using replace. I'm sorry, it's confusing. I didn't really write this well, but add an underscore in front of replace, and it's a sign that should work. And you should not be testing replace here. But I don't blame you. I blame me for not documenting this well. So this is If this person's watching or sees this, this is my fault for not explaining that nobody should use replace, and I didn't explain the difference well. I will clean that up. Disable TC in action with amount 1. This shows some issue with beam search on. If you have this extra option, the beam search is a lot crappier than if you remove the option. It's almost twice as slow. So it just shows kind of something's wrong with beam search. Level 0 runtime. We're putting this on hold. For basically kind of the stuff I'm working on today. Because do we really want to merge Intel crap? Not really. I don't know. I'm kind of done with that level. I'm kind of done with the level 0 level. I would merge Intel speedups for OpenCL. If someone wants to get Intel Tensor Cores to work, there is a $400 bounty for that. Would merging a dev container JSON? I don't know what that is. If you submit a PR and explain to me why it's useful, and who's going to maintain it and keep it up to date, then I'll think about it. Use true half for Onyx. Oh yeah. Wow, that's actually pretty bad. I didn't know there was a hack there like that. That's what George Hotz working on. Oh, this is my start of Intel Matmul. I'm convinced their API is just wrong. So you'll notice that I have to zero out half the matrix to make it correct. That was my reply to that guy who thought he was fixing stuff, but obviously I tried it without the divided by 2. I don't know. I think that it's wrong, and I think that it doesn't actually take in 16. I think it takes in 8 on the consumer GPUs, but they only ever tested this extension on the big ones. They didn't test the consumer GPU. So that's my guess about that bug, but it's also very possible that I'm just doing something wrong and don't have my local group size or something. Yeah, so there you go. There are some Tinygrad PR reviews. It's very accessible to contribute to. I've seen Saskatini around before. I really appreciate PRs like this. It was clear. My first thought before I clicked on the PR was, what happens if you do minimal on an older version, right? And if that's not immediately your first thought, this PR is not for you. Also, where's this slide from? from some GTC talk. Like, everything takes 350 milliseconds to compile on AMD, and I fixed it. Oh, you're in here. Cool. From some GTC talk. No, you didn't just source it. It's just cool that they're thinking about this kind of stuff. Okay. So we're gonna have to write all this crap to load in. We should probably start writing decent code. Like, I think we have to go past. All right. Let's write a new driver called KFD. I don't like that IO controls from header is a thing. I don't like that I need lib mmap stuff. Don't need munmap. I don't like that I need that. But whatever. I don't like that I need this either. I'm gonna actually just stick that. Sorry about having to construct it every time. Whatever, I'm not happy about that either. Oh. And we have to import KFD from the runtime. Okay. IO controls from header. I don't control number. Yeah, okay, I guess that's fine. Like, there doesn't actually have to be a whatever. I could merge that into one line. I probably should. And we should definitely be passing the FD in here. Either is TT2. Size is size of the struct. itype is org k. And NR is TT1. I think that's more readable. Oh, we shouldn't actually put that in the assert. Okay, cool. No, actually, what I really want to do is rewrite this to not be like that. Let's write this out a little nicer. So we're gonna have, let's say functions equals this, function subname equals, we just want to create a function. Well, actually, I can just use KFDIO control. Not exactly. I have to apply partial. Is it functools? That's good. Functools dot partial. And then the thing that I want to pass in. Oh, I shouldn't really say it's TT like that. I should ST. What kind of stupid names did I give these things? User struct. Oh, even user struct isn't isn't really right. Should I create a class? I do hate classes. I should really, okay, I remember the conclusion I came to before about this, which is that I need dynamic code generation. That like parses all this stuff and generates. I'm not really thrilled about that, but it'd be nice because it would give me no. KFD just calls into AMD GPU, so why are you looking into KFD? Well, AMD GPU is in the kernel. What do you mean? Like, I'm at the user space kernel space boundary. Where would you rather have me look? The actual driver is called AMD GPU. Oh, I mean, yeah, but this is, I'm communicating with the actual driver, right? Maybe I'm just calling it the wrong name. Okay, so the API is going to look something like AMD KIO get version, and then KIO see, that's not exactly what I want. I have to like create the struct and then call it. I don't think I can make the struct creation. I mean, maybe I can. Well, okay, I could pass in the user struct here and then have it create constructed user struct out of KW args. Move FD out here, KW args here. And then made, return made. Pass that in there like that. Like we can try that. Just put functions in here. KIO equals Ioctls from header. What else is frustrating about the whole AMD thing? It's like, why do you never explain your reasoning? Which was another really nice thing about, about dealing with Elon. Like, he just explains why. Okay, I want you to open source this. Give me a reason why not. Right? And give me a real reason. Don't give me some like corporate speak feel good shit. Give me a good reason. Just like be Be honest. I don't know why that's so hard for these people. Give an example of him explaining. You can even see, like, he does it plenty of times publicly too. I remember, it wasn't just about the Mobileye contract. He's like, you know, why would I pay out for something that I'm not sure that I can use? And like, again, sure, we can talk about, well, why would I build something that I'm not sure that I'm going to get paid for? But at least we're having a conversation at that point. No, they don't say there's no legit reason we don't want to. They don't give a reason. What they're doing is that they focus on managing, like they try to manage your emotions. And that's what a lot of that stuff was. It was like, it's focused on this form of management. Oh, we're going to manage our emotions. We're going to manage our partnerships. We're going to manage our client relationships. And when you manage something, you don't tell them the truth. You figure out, you're like, okay, I also think that like you manage enough and there starts being no more truth. Like you start thinking in this mindset for too long and there isn't an underlying anymore. There's just a, you know, perception is reality kind of thing. Maybe everyone's just terrified to put anything into writing. And they want to do phone calls. I'm like, I'm not doing phone calls. Why can't we just, like, this should be an email. I'm going to schedule a phone call, get people together. I don't want to waste anyone's time. All right, do we like the new API? Looks cleaner than that. Now when we want to like do something like acquire VM, we know the GPU ID. Let's see if acquire VM works. Let's also import this so we can. No, I have an idea, and you get like a certain type of person who says, well, George, that just isn't how the world works. And I'm like, well, why not? Let's change the world. Let's make it work that way. Seems like it'd be a much better world. And they don't see it as dishonesty. But they don't like... The thing about doing that is you're having a conversation then that's not at like the limits of your capacity. You're having a conversation that's... You're like just modeling the other person and trying to figure out, okay, well, what do I want from this person, right? It's not, the question's not what's true. The question is, what do I want from this person? And like, you know, how do I get it? I found in my professional life the people who love verbal communication were the exact same to conveniently forget what they said or agreed to. Yeah, that's kind of, yeah, I think that's exactly true. Which is another reason I much prefer to do things over email. I think there's just a lot less room for sort of miscommunication. You can quote an email. But yeah, no, they're very reluctant. Like, you know, I don't know what they say. Like twice they tried to like say, oh, we'll get on a phone call. I'm like, I don't want to get on a fucking phone call. What are we going to discuss on the phone? Why don't you just, you know, say whatever you want to say? But it's not like they'd say anything real on the phone calls either. I did multiple of these phone calls, and it's, I like, you ever, the example I always give is this time I went to a nail salon to get my nails done, and I listened to these two women talk, And, oh, quick call. Jump on a quick call. Let's jump on a quick call. What the hell is this? Allocate memory of GPU. Okay, we gotta do this VA address crap. Oh, well, actually, that is not right. We want the other one. Okay, let me create a higher level function. Actually, I can make this inherit from a class, can I? Oh, you're getting a phone call and they talk about their person. Oh, yeah, I'm going biking this weekend. Like, who the fuck cares? No, I mean, I've had phone calls like that. Like, they weren't, look, AMD wasn't that bad. I've had some, I mean, those phone calls I just don't do, right? Like, I'll only take a phone call. You know, I always say this to people. Here. I'll read one out. I'll read one out. It's from Cloudflare. And I don't mean to pick on Cloudflare. This is just the one that comes to mind. See if I can find it. Okay. Hi, George. I run blah, blah, blah team at Cloudflare. I would like to chat about an idea if you have time next week. Why would you send that email? Like this, I said, this is not how this works. We don't have resources for phone calls. What exactly do you want from me? Figuring out if there's any way we can help you succeed. They say a little bit more. But like, mostly that. Figuring out if there's a way we can help you succeed. If you actually just said, it goes on to talk about how they want to do inference on edge hardware. Okay, actually, you know what? I'll read the whole email because it is a good example, and I didn't reply to this person. Because like, the first part of the thing was figure out how we can help you succeed. I don't want to spend time talking to anyone who talks like that, right? While also helping us do faster inference at the edge on more limited hardware. Here's what your first email should have been. Hey, George, saw you work on Tinygrad. We have X hardware and we're trying to run Y model. Our current times are Z, but we'd like to have our times be W. We're willing to pay, you know, this problem is worth order of magnitude dollars to us. Can you help? That's an email I will respond to, right? That's an email I'll respond to. Is that so hard? Is that so hard for people? Is that so hard for people to read the questions document? If everyone hasn't read, I'm not going to start responding with skibbity toilet, although that'd be pretty funny. Be precise and informative about your problem. Volume is not precision. Questions not to ask. How can I use X to do Y? I tried X, Y, and Z on, that's an old Tiam motherboard, and that didn't work. I tried X, Y, and Z. Notice the curious symptom when I tried C. Right? Why do they never talk like this? Why do they always talk like this? Why can they not talk like smart people? because they don't care. I don't like saying that. I mean, I've heard like you'll get that a lot from like Jimmy Fallon talking about the Republicans won't pass gun control because they don't care, right? I think it's wrong to assume I think it's rude to assume somebody right away doesn't care, right? Like there might be other reasons for this. I do think that I like, again, having thought about this for months, AMD does not aspire to greatness, right? I'm not really even saying they don't care, and if I said that, that's going too far. I'm just saying they don't aspire to perfection and beauty and elegance and like things that make things great. They aspire to, well, all right, we'll do the bare minimum to shove it through so the enterprise won't, sue us. Stream chat has better questions than business people. All right, do we like the new API? Is the new API cleaner? I kind of like the new API. We're still on test KFD phase. This isn't actually a good driver yet. We're getting somewhere with these abstractions. The problem is I didn't like you can read my C code for NVIDIA, and I didn't slowly build up abstractions as I went. I just thrashed around. You don't need no reserve. That didn't do anything. I don't even know what that does. Actually, wait, no, we might need that in the future when things get big. It's just annoying. Okay, whatever. It has something to do with swap that I don't quite understand. From MLID, a leaker. Again, let's be careful about what do you mean a leaker? Like if someone like posts something like that, that's not like what I mean by a leak. Like that's not copyrighted, right? Like if somebody like breaks their NDA and like says words, I'm totally fine with reading that. I'm saying the problem is when you access leaked copyrighted data, your thing's not clean anymore. So you want to avoid doing that. Where do you have a citation for that? No, I don't care if it's an MID sort. Oh, MLID is just like it's like a. He has a YouTube channel. I mean, this might explain all of this too, right? One thing that could potentially explain, like, AMD's like I say, like, look, I want to write a beautiful driver for you. One thing, again, I wish like if someone like called me and was just like honest about that, I wouldn't tell anybody. I guess they don't really know that, right? But if someone's like, hey, look, man, like, but that's never, hey, look, man. It's like you're trying to manage some shit. I think it's possible, though. Yeah, I know. No, I probably wouldn't tell anyone either, to be honest. So you can't really blame them for that. If that turns out to be the case, if this stuff is masking like deep hardware bugs in RDNA 3, I mean, what do you do, right? What do you do if you taped out a $100 million chip and there's a deep hardware bug and it like kind of can never work? No, they didn't tell me. If they told me and like, again, if they like, engaged with me like that, come on, like that's just like, you know what it is? That's just like a shitty thing in like the world, right? Like no one wants that to happen. No, look, if that turns out to be true, if all of these problems are deeply just the hardware is, look, sometime the hardware flummoxes and, well, oh, MLID is Moore's Law is dead. Oh, I know that. No, they're not. There's no conspiracy between. They're like second cousins, and like Taiwan's a small island. No, I mean missed design goals it is possible. I still only think it's like 20-30% likely, but it is possible that this scheduler in RDNA3, it has nothing to do with like in order and out of order execution. Just fundamentally the hardware like sometime doesn't work. Though usually you can mitigate things better than that. So again, I think it's pretty unlikely, but I'll read the analysis. Yeah, we'll take a look. We love bashing AMD in this stream, but only in a positive, constructive way, which is that they should release their shit. But if there's a hardware bug, right, I totally get why they don't do it, right? Maybe it's that. Alright. That's not working. We wanna Malik there. Gotta take a look at these again. These flags are pretty important. So what's the difference between user pointer and GTT? What's user pointer? A phone call from the government trying to push backdoors into your products? Yeah, I think that, yeah, I believe that happens. Again, what are they going to do? If I ever got one of those national security letters that you're not supposed to talk about, I'd just post it online. I'd post it online, and if you want to put me in jail for that, you can. Like, I think that's just so morally wrong to do to people. Yeah, well, most people are pussies. We've talked about this. You only got one life, man.
Or, I mean, like, there's a more to NVIDIA, and if they weren't going to win performance, they at least had to be able to make it look like they were more efficient, even though they really aren't. And that explains this weird naming, the weird bumbled clock speeds, everything. This launch was just rushed, and that is what I think has compounded their bad decision making. I honestly think this launch was rushed. And I actually think it was rushed for 3 reasons I'm going to get into now. Number one, Lisa Su said that they would launch RDNA 3 this year, and from what I hear, she wants to keep up the perception with investors that AMD always launches when they say they will, unlike Intel, and that to investors, a delay looks worse than a bad launch. At least if they have a tepid this Easter season. Now, as you probably already noticed, this isn't one of those videos where I put 1,000 quotes or an entire PowerPoint on screen for a bunch of hyper-specific leaks. I'm going to put a quote on screen soon, but for the most part, this video is about telling you the backstory and the mentality of the engineers at NVIDIA and AMD. So don't look for a bunch of things to screenshot and share. Maybe just listen to what I'm saying. If you want to share what I said, actually.
What's RTG?
Or to NVIDIA. And if they weren't going to win performance, they at least had to be able to make it look like they were more efficient, even though they really didn't think it would turn out as bad as it did. And so, yeah, that's basically my summary of what I believe went wrong. AMD had a good architecture on paper. They had an architecture that in simulations performed where they wanted it to, and they had an architecture that physically, when they tested it, always performed where it was supposed to in some games, to the last minute, where the average fell way short because they just still haven't finished the drivers. They cherry-picked their results that they presented on November 3rd because they thought they'd get the average up, and at least as of now, they failed to. But they accepted this failure because they had multiple reasons to rush this launch so that it would come out at the end of this year instead of next year. That's how we get into this situation. Now, there are 2 more things I want to...
Interesting. I mean, I don't know. Look, you basically like I don't know. Well, waste. A lot of waste. Why are people dishonest? Why don't they just like, if your shit's not ready, don't launch it. Can I get this but longer? Can someone find a good one of these where that's not even totally up to date? I mean, it's bad. If AMD falls to too small a share of the market, they're going to shut it down. They're no longer going to be able to 219. Can we find this but up to date? Can someone find it? Oh, user stats of Steam? Is that, can I get that? I don't know what that means. Okay, so this is sorted by popularity. Interesting. Intel Radeon graphics, Intel Radeon TM graphics. No, what? That bug is. The PlayStation 6 will still use AMD. Yeah. 2021. No, I want to know recently. Whatever. Doesn't matter that much. All right, chat. You're going away for a while. You haven't been saying anything good. You got me distracted on dumb shit. Oh, flags. Can't forget about flags. So this is if I do it in VRAM, that doesn't work though. No, it does work. Wow. But no, it's the second mmap that fails. So we can just do like a normal mmap there. Map private, map anonymous, map no reserve. They're pretty cool. Well, no, now we gotta get back to buff, so we can use 2MV. That's if you're doing the DRMFD. If you're doing GTT, I don't think you do it like that. Oh, I should assert that buff's not, that's fine. It's still returning an mmap offset? Interesting. Like, I wonder if that does anything. What about user pointer? Okay, it doesn't work for user pointer. Oh, because I mapped private? Have to pass in user pointer there too. Whatever. I don't really understand this. If I do map share, does that work? Yeah, that works. So why do I even have to? What if I don't put an address in here? Oh, interesting. What if I don't set VA address at all? Does this set VA address? Just not have to? That never made any sense. Yeah. Does VA address get set on the way out? No, it doesn't. But this might be okay if I just put 0 in here. No, that doesn't work. It's interesting that allocate memory works. I wonder if it's actually putting that at address 0. So it does need to like allocate it, sort of. Okay. Get version of car VM, alloc memory of GPU. That seems pretty good. That's giving us GPU memory. Now how do we allocate a queue? Ring base address is buff. Ring size is that. GPU ID is GPU ID. Queue type is that. Queue percentage, which I don't really understand, is that. Queue priority is that. Write pointer address is that. Read pointer address is that. Failed to look up we pointer bow, but that happened because I didn't map it to the GPU. We know about this problem now, so we can map that to the GPU. How do we map memory to the GPU? Cert success is 1. Wait, I should just be able to do this. It might free before I... It's a little sketchy. Device ID's array pointer is address of that. Handle is mem.handle. And end devices is 1. Cool. I mean, I kind of want to make something that like wraps this as a class. I guess what I could do all the functions start with AMD KFD IOC? Yes, they do. Okay, we can remove that. We can make it lowercase. It's a little nicer at least. So then we can just do kio.getVersion, kio.acquire VM, kio.alloc memory of GPU, kio.map memory to GPU, kio.create queue. That looks nicer, right? Except I broke it? How did I break it? Oh, an MES error. Oh, hey! Hey! I found... There you go. Is that repeatable? I'm looking at chat again. Seeing what you guys think about that. So now just don't use it? No, but there just shouldn't be MES errors, right? There shouldn't be ways. Create queue type 0 failed. But is that a repeatable crash? So when you get this stuff, fail to respond, it's all right, let's push this and let's reboot the computer. We can try resetting the GPU, but I don't think this works better. Oh, see, now the GPU is in a broken state. Like this is what I struggle with. Now what the hell do I do, right? So I don't actually think that deterministically breaks the GPU. Yeah, you get this failed to write reg garbage. Did it reboot? Oh, now there's no more KFD. KFD is locked. Cannot create process. God. Now, let's point something out. Somehow, from user space, calling normal APIs, I got your GPU into a state, like this is the shit. Up there, oh, it worked. Oh, it worked that time. Great. What crashed? Is there a crash dump? Is there any normal thing that like I can send to AMD and be like, yo, your GPU crashed? I did all this with NVIDIA GPUs. I never crashed it once. They have a stable user space kernel API. Most of the client code is about hiding these problems. Yes, this is what I'm saying. It very well may. I don't actually. It might be hardware. I mean, the hardware might just be broken. Why else would they not want, like... Now just don't use it. Yeah, now just don't use AMD GPUs. Like, this is my whole experience with it. There is nothing that you should be able to do. Oh, it's gone again. And it's gone. Oh, that time it worked. Oh, there we go. It's in a broken state now. It's in a broken state where every time I talk to it, we get this. All right, we gotta reboot. But to be fair, I'm doing stuff that's a little, like I'm probably not using all these APIs exactly correctly. But that's not how this should work. You need to write a fuzzer. Should we write a fuzzer? I mean, now it's pretty, I think I know how to write a fuzzer. Tinybox isn't going to be RDNA 4. I'm never doing this again. I'm never buying these GPUs again. I don't trust this company one bit. We're going to build our own GPUs. And then I'll hide hardware failures from you guys. I'm kidding. If I had hardware that was broken, I wouldn't sell it. Sell every AMD. This isn't going to get better, guys. They're too busy working on RICL. I'm telling you. They're working on RICL and MI Open and, giving puff pieces about how AI is giving puff speeches about how AI is going to change the world. Let's do this. The future of your PC is AI.
Opportunity to really show everyone when you bring everybody together, you can actually have a better solution with such a rich ecosystem. Great hardware, great software, great partners. I think we're going to learn a lot over the next few years. But the way I think about it is cloud AI, of course, is foundation. Right? You need to have a very, very powerful cloud infrastructure. There's also a lot of opportunities for very special...
Does someone want to make a mashup of this and MES crashes? Yeah, that's what I'm saying. Like do a mashup of,
In those cases,
talking about AI puff bullshit and intersperse it in MES crashes. You had a meeting, they pulled all people from GFX projects onto Compute AI. Well, are they going to fix the MES? But no, what they don't do, I can send them this crash. I can put this in a while loop and I bet you it crashes repeatedly or something. Or maybe I just have to like add in a few random randoms somewhere. But there should be no way to crash, and that had to be rebooted. All right, let's try it again now and see what we get. There should be no way that this can break from user space. You know that your shit's fucked if I'm always opening a window and running sudo dmessage w in it. Okay, that time it worked. Oh, you found my issue? Has it been closed?
AI, or what we call the client side or edge side with Ryzen AI can be very, very powerful. What I view is a world where everybody's life is improved by AI. We can all become more productive. We can all become smarter.
Oh, I didn't know. I'm getting MES failed to respond. And don't worry, guys. Don't worry. They fixed it on 063. Don't worry. They fixed it on 063. Are you fucking kidding me? Wow. I didn't realize there was other people commenting on that issue. They're never going to fix it, guys. You can either sell your hardware or, nope, sorry, that's your only option. Sell your hardware and buy NVIDIA. What did I even do there? All I did was create a queue. All right. Hey, look at that. Pretty repeatable. Now, to be fair, I am creating the ring buffer on GPU memory and not GART memory. But that's probably wrong. You probably should create it on GART memory, but I'm not even fuzzing, guys. I'm not fuzzing. And now it's fucked. I'm not fuzzing. I'm literally trying to use the thing. Nope, you have, this is, okay. Instead of fixing any issues, they shove mitigations in the wrong place. So as soon as you go right to the kernel and you try very reasonable things, fine, maybe I'm using the API a little bit wrong, right? Maybe it doesn't work. Maybe it throws an error. It doesn't crash the GPU. This is completely unacceptable, and it's not going to get better. Disable IOMMU? I'm sure I don't have the IOMMU enabled. How do I check? I'm happy to disable the IOMMU. Okay, I do have the IOMMU enabled. Happy to disable it. Yeah, let's disable the IOMMU. What do? IOMMU off? Who wants to make a bet that this doesn't fix it? Disable AMD IOMMU here. To enable IMU, to disable IOMMU. Okay. Grub command line Linux equals, no, that's junk. Wow, I can't believe I used that script. Also, do I want to put it in Linux default? Do I want to put it in Linux default or CentOS? Options in grub command line Linux are always default. Okay. What do I do? Grub config or something? Grub CFG. Sudo update grub. Okay. Still, it would be good to fix the queue creation code. Yeah, we're gonna fix it, but I mean, again, why don't we write a fuzzer? Why don't we? You want to write them a fuzzer? Okay. So we disabled. Like, they have the complete wrong mentality for writing this shit. All right, let's go. Let's see if it'll crash again. By the way, we very much welcome any fuzzing of anything in Tinygrad. I love fuzzing. Up! Hey! Hey! Was it the IOMMU? IOMMU disabled. Hey! It's still a piece of shit. Hey! Alright, AMD, there's another crash. There's another crash. I'm being your unpaid QA team. Ice Leo, thank you for gifting more subs. Is there a way to tell if it's the firmware or the hardware? No. No way to tell. Alright, GPU reset succeeded. Did it reset? No, now it's just hanging. No, but like, the thing is, instead of figuring out what the root cause of this problem was, they'll stick 3 more if statements in the kernel. But I have a complete, okay, you guys saw this. I have a completely repeatable way to trigger this error. It's not even a race condition. It's a completely repeatable way to trigger the error. I just run this program 3 times. Oh, good. They fixed the demub. Good to know. All right. Should we package this up nicely in a gist? Why isn't AMD playing ball? Because it's a hardware issue and they don't want to tell anybody. Alright. Let's move this over. This is in no way ready for Tinygrad. Let's move this over from Tinygrad, runtime, Tinygrad, runtime, driver, KFD. We'll move that here. We also need the file that I import. Tinygrad runtime driver Tinygrad runtime KFD goes here. Should we change the title of the stream to Being AMD's Unpaid QA Team? That one was fast. Wait. No. Do you guys... You know what we could do? We could... anywhere they think that they're shipping SRIOV to allow multiple people on a GPU. Are there clouds with these things? Like, it's like, this is like a kernel crash. Let's rent cloud and spam this shit. No, I don't think they understand how bad this is. And you know what? What day is that issue from? What day is that issue on GitHub from? May 30th, 10 months ago. All right, you want to reproduce this on a Tinybox? And then we'll try upgrading to their latest version and making sure it still happens on the latest version. And then we'll report the bug. This has a different issue. Okay, different issue here. Oh, that's not even a oh, probably because it has a different GPU ID. I have to actually get the GPU ID. We can't just hard code it. Where do I get the GPU ID from? Azure still in public preview. Wonder why. Oh, I know the user. Oh, I gotta do that. Actually, why did I kind of want that print? I like that print. Oh, space left on device, eh? Actually, wait, better than that print, what I really want is a try accept import error pass. Okay, eventually you get no space on device. Okay. Oh, that time I got error. There we go. Okay, now, because I'm a nice person, let's update to their latest release shit. Probably shouldn't have that in there because, you know, if you don't have that, we want to make sure. No, I'm sure that's not related to the crash. So there's a repeatable, like basically kernel crash. Maybe read the GPU ID from an environment variable. No, I can just get it from here. That's a good point. I shouldn't just talk about it. It's lazy of me. Let's see what we can find about. They posted it on Discord. Well, no, but oh, I'm sure it affects CDNA. I bet you the same bug. I bet you could run this on a CDNA system and it will do exactly the same thing. It's the same code. I mean, should we try it on the latest version? Should we try it on CDNA? I don't know what's going to get through to these people. Like, that this is totally unacceptable. I think at this point, you know, yeah. Don't just offer to buy back my GPUs. Offer to buy back every single RDNA 3 GPU in existence. All right, here's the instructions for installing the release candidate. All right. probably wanted to overwrite that. So you see we're on the new version. Alright, so don't tell me to try the latest version. Yeah, I don't know. Should we start? I mean, we can go after CDNA. We can find them. We can write a fuzzer and find MES crashes there. I'm giving them till Monday to say, look, we agree this is fucked. We're gonna release our firmware. We're gonna, you know, here's some docs. Here's what we can release today, and we're gonna make it, you know, here's the process, and we're gonna release all our firmware. Because nobody should buy these cards, and we'll hit the MIs next. No, I mean it's an addiction. It really is. Oh, has no one reached out yet? No. They've reached out. I emailed with Lisa Sue yesterday. She just doesn't think this is important. Like, I got bullshit back. So we'll make it important. I don't know. Watch some videos of her. First, we're trying the latest version, and now maybe if we start attacking some MI instincts. Where can we rent? Funny. I really haven't seen them anywhere either. Oh, you can't rent them. Oh, I wonder why. Can I get an MI300? Well, you know what? I have some MI25s. Great hardware, great software, great partners. Yep. No. This is the one they said they fixed it by switching the queue from in order to out of order. Like, is there any fuzzing at all on this layer? There is no way that any kernel commands should crash the GPU. We can try. Maybe firmware 9's less buggy. I mean, there's a chance they're less buggy. There's a chance they're less buggy, and they just don't give a shit about, you know, RDNA 3. But from what I've seen, it's not like one bug. It's the whole process that's broken. It's not that it's too many bugs. It's that it needs to be re-engineered from the bottom up. Release the firmware and release the docs. I'll do it free. To be fair, and again, I wish you would just say this if this is the case. You're like, well, I'm not going to give you our firmware. You've already said what you want to do is, use our GPU to develop a driver stack and then build your own GPU, and we don't want to help you. That's totally fine, but that's not what they say. I get bullshit. I get bullshit that says they care. They don't care. I get bullshit that they say they care, and then it doesn't work. Say you don't care, and we're done. That's great. That's then your words align with your actions. Oh, you need to sign an NDA. Oh, you need to sign an NDA to use the MI. Oh, no, that's just Azure. Whatever, man. That's not. Yeah. Do you have to sign an NDA to use an H100? No, I can just go right on Vast AI, and I can go right here to on-demand pricing. And, oh, look, an H100 right there. I can buy it for $275 an hour. By the way, we're still installing HIP. No, there's a way to make apt multi-threaded. There's like a command you can use. I've done it before. Oracle doesn't let you publish benchmarks. AMD doesn't let you publish opinions about their new GPUs. It's not against NVIDIA's terms. You guys are obsessed with NVIDIA's terms. NVIDIA's terms literally, all NVIDIA's terms say is Azure, do not host 4090s or we will be upset with you and not give you allocation for H100s. That's all NVIDIA's terms say. No, you can't rent them. They don't work. You know how you know they don't work? Go on MLPerf. Have you seen AMD? Why isn't AMD not compared, despite George Hotz, Lisa Su's plan to get AMD on MLPerf? AMD does not do ML. They don't have the capacity and engineers nor desire in their leadership to develop their software stack. AMD has had excellent hardware and has years now to get anything going. They didn't, so our best guess is they won't. ZWAPs, I wish I just listened to you. Look at my tweet. Go on my Twitter. I told them I fixed this for them. They're not serious. I think the hardware might be broken. If the hardware's broken, just be honest with me and don't treat me like you're managing a relationship. It's a hardware issue for consumer cards. Yeah, I mean, maybe the hardware issue's fixed on, I don't know. But who's WAPs? This is exactly how they manage comms if they have a hardware issue? Yeah, sounds right. Let's spread that rumor. Could everyone go post on Twitter right now that the real reason AMD won't release their firmware is because they have a hardware issue? Let's wait forever for the Tinybox to boot back up. maybe I should have just installed it on this computer. Oh, is this broken now? I don't know why that's broken. Let's turn it off and on again. Crashed real bad that time. Find a bug which permanently bricks it. I mean, I don't think these bugs are going to permanent brick it. But it does seem like my computers don't want to reboot. Oh, okay, that one's back. Alright, so now we're on the latest ROCm. Let's print the firmwares. Is that not it? Alright, so we just go in here. We run the loop. And it crashed. Oh hey, it's the new firmware and it crashes. Wow, looks like it even crashed harder that time. Look, they added some... Look, it's different now. They added some retry shit. Oh, it's staying up. Wait. The error is definitely different on here. It definitely looks like they switched a queue from in order to out of order or some shit. They improved something. Alright, class action lawsuit for all RDNA 3 owners. The hardware is broken, guys. They sold knowingly defective hardware. Alright, I don't know. I'm not wasting any, like, I don't want to waste my time writing a driver for that. Should we tweet that one? Should we tweet the crash? That's repeatable. I repeated it on 2 computers. It's almost instantaneous, and I tested it on 063. What else do you want from me? If anyone has a CDNA, does anyone have CDNA? All right, let's replicate it on the cloud. All right, where can we rent MI anythings? Now, to be fair, there's a chance it won't work. I don't have an MI250. No, you don't understand. They're not going to fix it for the next gen. They as a company are structurally incapable of fixing this. Like, I wasted months like engaging with them, thinking that, oh, this is a bug that we can fix. This isn't. Right? Where's my GitHub issue? Where's my GitHub issue that was open 10 months ago? Right? And also, if the reset works, it doesn't really matter? No, the reset doesn't work. I have to reboot the computer. Think the reset works? Now it's just completely frozen. Also, if the reset works, even if the reset works, it totally does matter. That brings down your whole training job. Right? And the reset doesn't work. I now have to reboot this computer. The power reset works. Yeah, that's true. And I think I actually have to be careful about how I reset this computer now or it won't come back. Right? I know that, people are going to think, oh, George gave up on getting AMD on ML perf. I really tried, guys.
But what can you do? What can you do when just like, you know, you're trying, again, George, you're not using the API correctly. I can replicate this using the API correctly too, just not as quickly, right? I can replicate this in HIP. I can replicate this in Torch. I can replicate this in anything. Just the reason that you go to this level is not because, oh, I ran Stable Diffusion in Torch once and it didn't crash, it's fixed. This is not how you fix bugs. Gradient accumulation, but you accumulate by saving to disk and rebooting out of band, not in band. You have an external Raspberry Pi monitoring your AMD GPU and sending a reset to the BMC. All right? Let's hope it comes back. Now, again, like, oh no, the custom extensions you need for a Tinybox Green too. That stuff is universal. The NVIDIA PCI controller is a little better, but not much. All right, so yeah, who wants to find some cloud machines, or should we improve the fuzz? I mean, I can't even improve the fuzzer, right? It's not even like I can fuzz better. I have a 100% repeatable crash. I'm going to hit the same crash over and over again, and this crash is completely unfixable. I'm not doing anything. I'm literally, all I'm doing is creating queues, and it's not a notice how it's not a deterministic crash, right? It's not like, you know, you have to run it in a loop in order to crash. But all of these things look like this. And it's because they don't root cause any issues. They just slap some stupid mitigation on it and be like, can't replicate. They fixed it? What? Who fixed it? Oh, God. No. See... Pumping Trash 3.0 and hopefully 4.0 next year. Did my computer come back? Sometime when the GPU crashes badly, it doesn't come back, and the only way to get it to come back is to do a BMC reset. Fortunately, because this has happened so many times, I made a script to make this easy for me. AMD layer norm. No, don't worry, guys. Wrinkle's coming, guys. No, nothing works on these cards. You don't understand. It's not PyTorch that can be better. I'm doing a relatively simple thing with the kernel API in a loop, and it's kernel panicking the card. Oh, I mean... Wait, yeah, no, I mean, this really only works. These crashes to bring things down really only work if they are, yeah, on a VPS, you're only crashing your own machine. Right? But if there's any shared machines that use AMD GPUs, I'm sure all these crashes work. $5? Can I rent an MI? Like rent it for a long time. interesting. Alright, I'm disheartened. I don't do this anymore. I'm not even gonna tweet the crash. Like, it's not gonna get better. It's not gonna get better. Why do you keep doing this to yourself? It's an abusive relationship. I'm not stuck with AMD. Like, I like this driver interface, and like it was kind of fun, and like we were gonna go through and create a queue and launch a thing. We can still do that. You wanna still do that? You wanna still do that and just try to work around the crash? Slowly work around the crash a little bit at a time. Oh, is it worth the effort? No. Yeah, what about the next 10? I know. I mean, okay, do you want to try to make the crash repeat? The problem is every time it crashes, I have to reboot the system again. How are we going to get through to them? You help the scene a lot. You ordered AMD GPUs. Don't do that. If you're not a masochist who loves dealing with this kind of shit, unfortunately I'm a masochist and love dealing with this kind of shit. But if you're actually an ML startup trying to do, you think Comma owns a single AMD GPU? Why can't we just let AMD gradually die? What about, come on, like, we don't want that. That just sucks. You want to crash it once more? Let's crash it once more. Oh, hey, look at that. You learn the hard way. The startup costs many months. Yep. I'm convinced now also, judging from how it crashes differently on Tiny 13, that they lied about the queue thing and they actually just shoved a retry somewhere. No, it's just as consistent on the other thing. It just like it flips between two things. I think they just shoved a retry in there. And they don't say, like, that might also explain why that PDF made no sense. Right? Part of the reason this PDF might make no sense, like what committed in order or out of order, like this might be complete nonsense. Let's write the real version of this PDF. There is a deep hardware bug with RDNA3 that is triggered by this use case. We can't predict when it's going to happen, but we shoved a while loop in there to retry things and flip a few different flags in hopes that they'll work, right? TPM wrote this PDF. Yeah, why? It's gonna take me years to take chips out, guys. Like I like this. I like the KFD programming model. The KFD programming model is pretty nice. I like that it's like create queue. NVIDIA has you do so much stuff before you can create a queue. I like that it works. I like that it describes the 4 types of memory. I just wish that it was reliable. Like I wish that you just couldn't trivially crash it. I don't actually think it is. Like, if it's hardware, it may not be hardware related. This may very well just be the firmware. What if I make a really cool interface around Tens Torrent? Those cards are a toy. They're not really worth, like, they're fun to play with, but they're not a serious ML. Make a cooperation with Tens Torrent. You could do the software side. I offered. I offered. That's originally before I started Tinygrad. I was gonna do the software on TensTorrent as a contract. You know, I don't blame them. I think that they weren't ready. Gather everything. Crash in PyTorch, HIP, Tinygrad, and cDNA, RDNA. Display it so every fucking idiot can understand it. Hint at problems that occur in production because of it. That's probably the best way to get attention around it. But like, I don't know. I think we're just being lied to in some way I don't really understand. Like, I'm not sure attention is the problem. There may be something they'll never admit to. Jim Keller thinks the software part is easy. The software part's the only hard part. Post a reproducible gift for sure. It's in my repo. It's in my repo. Abusive relationship. Abusive relationship. Yeah, their ML market share already rounds down to 0, and it will continue to round down to 0 until they take this seriously. Alright guys, that's it. That's today's stream. Whatever you're doing, if you are trying to do serious ML, do not buy AMD. I'll send an email right now with that MES crash. Bye guys.